So with our dice images, at least for me, they're kind of big, and I'd like to space them out a little bit. Our last step is we're going to go back to our CSS style sheet. I will select the ID of dice result. That's going to be for this title right here. I'll add some margin around this text. Right now it's kind of compressed. I will set margin of 25 pixels. Then with our dice images, ID dice images, with my ID of dice images, take each child image, set a width of 150 pixels should be good. Yeah, they're a lot smaller now. I'll add a little bit of margin too. Margin, 5 pixels. Yeah, that's not a bad looking program. Alright everybody, so that was a dice roller program you can make using JavaScript, HTML, and CSS. Impress your friends. And that's pretty much it. Hey, what's going on everybody? So in today's lesson, we're going to create a project where we generate random passwords. This will help us solidify our understanding of functions and random numbers. This will be an exercise for beginners. By setting different options, we can change the format of the password. And well, let's begin everybody. Alright, let's begin. We'll need to let our program know what the length of our password is going to be. Let's create a constant to store that. Const password length. Set this equal to maybe 12, but we can adjust that accordingly. We'll create a boolean to specify if our generated password is going to contain lowercase characters. We'll create a constant, include lowercase. Do we want to include lowercase characters? We can set this to be true or false. We will set this to be true. Do we want to include uppercase characters? Include uppercase. I will again set this to be true. Do we want to include numbers? Const include numbers. I will set that to be true. Do we want to include symbols? Const include symbols. We'll define a function at the top of our program. Function to generate password. We have a lot of parameters to set up. We're going to pass in all of these constants as arguments. So we have a length, include lowercase, include uppercase, include numbers, and include symbols. When we call this function, we have to pass in all of these arguments. So we will call our generate password function, pass in our password length, include lowercase, include uppercase, include numbers, and include symbols. At the bottom of our function, we will be returning a password. But for now, I'm just going to write an empty string, because we still need to determine what that password is going to be. After finishing the generate password function, this will return a string password. We will store that within const password equals whatever is returned from the generate password function. And just so that this is more readable, although not necessary, I'm going to place each of these arguments on a new line because I'm OCD about things being in alignment. And then at the very end of this program, I will display a template string of generated password. I'll add a placeholder, then we'll display our password that we generate. So right now, it's not going to display anything. We're returning an empty string. But that is everything we need outside of this function to generate our password. Basically, we're passing in options when we generate our password. Do we want to include lowercase characters, uppercase characters, numbers, and/or symbols? We have a number and a bunch of Boolean values. Within our password, we're going to create a few constants within this generate password function. We will create one long string of all of the lowercase characters, chars, equals, I'm going to go through the alphabet. We will have one long string of alphabetical characters. And I think I got all of them. So there should be 26. Now we're going to do this with uppercase characters. Const uppercase chars equals, I'm going to turn on caps lock, go through the alphabet, we'll create a constant of number characters. Number chars equals 0 through 9. And symbols. Const symbol chars. Which symbols would you like to include? I'll just add a bunch. That's probably good enough for now. Feel free to add more or less. We will create a variable for allowed chars, meaning characters, and an empty password. Let password equal an empty string. If some of these constants are true, we would like to take that corresponding set of characters and concatenate it to the allowed char string. So what we'll do is take our allowed characters variable, use string concatenation by using plus equals. We'll check to see if include lowercase is true or false. We can use the ternary operator for that. If we would like to include lowercase characters, we will string concatenate our lowercase chars, our lowercase characters. Otherwise, we'll concatenate an empty string. Let's do this with uppercase characters. With our allowed characters, let's string concatenate and check if we're including uppercase characters. Question mark. If this is true, we will concatenate all of the uppercase characters we've declared. Otherwise, we'll concatenate an empty string, so we don't include them. Let's do this with number chars. Include numbers. Are we including numbers within our password? If so, we will return our number chars string. And then symbols. Are we including symbols within our password? If so, concatenate our string of symbol characters. All right, just to test everything, afterwards, I'm going to console.log our allowed characters. So right now, I'm going to switch all of these constants to be false. So right now, we're not including any characters. If I were to set include lowercase to be true, we would include all of the lowercase characters. That's one long string. Let's test uppercase. Yep, we are including all of the uppercase characters. Include numbers. Yes, that works. And include symbols. That also works. At this point in the program, we're going to have one gigantic string of all of the possible characters. Before we move on with the program, I do want to run some checks using some if statements. First, let's check to see if the password length is 0 or less than 0. Right now it's set to 12. Using an if statement, if the length of the password, is less than or equal to 0, we need to let the user know that the password length must be at least 1. We will return a string. Password length must be at least 1. Right now we're not generating a password, we're returning an empty string. If I set the password length to be 0, we will generate this message. Password length must be at least 1, or even a negative number, like -1. Password length must be at least 1. Let's set that back to be 12. What if we don't select any options? What if all of these character options were false? We can check the length of our allowed characters variable. So if our allowed characters length property is strictly equal to 0, this will only be possible if all of these options are set to false. We will return a template string. At least one set of characters needs to be selected. And let's see if this works. Yes, it does. At least one set of characters needs to be selected. I can select any options that I would like. I will set these all to be true. Now here's the hard part. For as many iterations as our password is, we will select a random character from all of the different possibilities. We will use a for loop. We will let I be our index, our counter. We will continue this for loop as long as I is less than the length, the password length. Then increment I by 1 during each iteration. If our password length is 12, we will execute this for loop a total of 12 times. Now we will generate a random index. Const random index equals, we will use the random method of math. This generates a random number between 0 and 1. I can multiply this number that's randomly generated by the length of our allowed characters. Let's say we're including only lowercase characters. Well, this is a total of 26 characters in the alphabet. If I'm taking math.random times 26, I'll be given a random number between 0 and 25, but I will need to round it down. Let's enclose this equation with the floor method of math to round down. Math.floor. We'll use string concatenation with our password. Currently our password is an empty string, but we will use string concatenation. We will string concatenate a randomly chosen character from our string of allowed characters. Password plus equals our allowed characters at the index of random index. Then at the end of this program, we will return our password. And let's see if this works. Let's close out of this function. We don't need it anymore. And let's see if this works. Yeah, there's our password. So every time I run the program, I get a new random password. And I can turn these options on and off. Let's set all of these options to be false to begin with. And I will set the length to be 0. Let's see what happens. Password length must be at least 1. Alright, how about a password of 10 characters long? At least one set of characters needs to be selected. Let's select only lowercase characters. Yep, we only have lowercase characters. Let's allow uppercase characters now. Let's allow numbers. I didn't get any that time. Let's do it again. Okay, there's a number. I guess numbers don't come up very frequently. And let's include symbols. And there's a few symbols in there. Alright everybody, so that was an exercise to generate random passwords. It should give you some practice with functions and working with random numbers. And well everybody, that was a random password generator in JavaScript. Hey, welcome back everybody. So today I gotta explain callbacks in JavaScript. A callback is a function that is passed as an argument to another function. They're used to handle asynchronous operations such as reading a file, network requests, or interacting with databases. These activities take some time to complete. Now with JavaScript, we don't necessarily wait for a process to finish before continuing with the rest of the program. For example, if we were to read a file, if it takes a long time to read that file, JavaScript might continue on with the rest of the program. We might attempt to display the contents of that file before we're finished reading it. That's where callbacks come in. We're telling JavaScript, hey, when you're done, call this next. When you're done reading the file, then display the contents only after that process is complete. I'll give you a few examples of the syntax of a callback. We'll start with something really simple. We'll create a function to display the word hello. This will be the hello function. Then I will console.log the word hello. So I can invoke this function, hello, to execute it. Hello. What if we were to create a function for goodbye? Function goodbye. We will console.log goodbye. Okay, after hello, let's invoke goodbye. We have hello, then goodbye. What if my hello function takes a lot of time to process? Well, JavaScript isn't necessarily going to wait around before executing the goodbye function. I'm going to add a few lines of code You don't need to copy this. These few lines of code are going to make us wait for 3 seconds. You don't need to write this down, but do pay attention. We will execute the hello function followed by the goodbye function. But we're going to pretend that our hello function takes a little bit of time to process. So now we have goodbye already executed, followed by hello, but it should be the other way around. I would like to guarantee that the goodbye function follows after the hello function. Well, I can do that by adding a callback to the goodbye function after the hello function is complete. We'll get rid of this goodbye function invocation. To use a callback, you pass a function as an argument to another function. We will pass the goodbye function as an argument to the hello function. So within the set of parentheses, type the name of the function, goodbye. Now be sure you don't add a set of parentheses after the function name. You'll call it right away. We are passing the name of the function as an argument. But we need a matching parameter. I will name this parameter callback. After everything within this function is complete, let's take our callback, then invoke it by adding a set of parentheses. Invoke meaning call. All right, now let's see what happens. We have our hello function, followed by the goodbye function in that order. Let's create another function. What about a leave function? We'll tell somebody to leave. Console.log leave. I will pass the name of this function as an argument to the hello function. Leave is now our callback. After executing the hello function, we will execute our callback, and in this case, it's the leave function. Let's create another function for wait. Function wait. Console.log wait. We'll pass the name of the function as an argument to the hello function. Wait is now our callback. We will execute the hello function, followed by the wait function. So by using callbacks, we are guaranteeing that the function passed in will execute next. You can pass callbacks as well as other arguments to a function. Let's go over a second example. I will create a function to sum two numbers together, x, y. I'll also add a callback. Callback x, y. We have 3 parameters total. Within the sum function, we will create a local variable of result, add x plus y, and then I will call my callback. Then I'll pass the result as an argument to the callback function. Then I will create a function to display the result to my console. Display console. There is one parameter. We have a result argument we're receiving. Then console.log my result. All right, now we will invoke the sum function, but we have 3 arguments that we need to pass in. A callback, a value for x, and a value for y. Let's invoke the display console function as a callback. Again, be sure to not add a set of parentheses after the name, because then you'll invoke it right away. X will be 1, y will be 2. And let's see the result. The result is 3. So within our sum function, calculate the result first, then after that process is finished, then display the result to the console. Let's create a separate function to display the result to our document object window, our web page basically. Let's pretend that this wasn't here. I'll create an h1 element with an ID of my h1. I will create a separate function, display page, to display on the web page. I think display DOM would be more appropriate, but I haven't explained what the document object model is yet. So let's just work with display page. We will accept a result. I will change the text content of the my h1 element. Document.get element by ID. The ID was my h1. We will change the text content to equal our result that we receive. As a callback, we will use the display page function. Display page. There, and the result is 3. After this calculation processes, execute the callback, and this time we are passing it to the display page function that we created. All right, everybody, so that's a callback. It's a function that is passed as an argument to another function. They're used to handle asynchronous operations, operations that may take a variable amount of time, such as reading a file, network requests, or interacting with databases. We're not exactly sure when these processes are going to complete. By using a callback, we can ensure that a function executes after these processes are complete, and not before, accidentally. All we're doing is saying, hey, when you're done, call this next. We'll have more practice with callbacks, especially in the upcoming topics. And well, everybody, those are callbacks in JavaScript. Hey, it's me again. Today I'm going to explain the for-each method in JavaScript. The for-each method is used to iterate, meaning loop through, the elements of an array and apply a specified function to each element. You have an array. We can use the built-in for-each method of arrays and send each element through a callback to a function. Here's an example. I'll create an array of numbers. Let numbers equals 1 through 5. Then I'm going to create a function to display each element. Function display. There will be one parameter, an element. We will individually display each element within this array. Console.log each element. I can display each element of this array by using the for-each method. We will take our array, dot, use the built-in for-each method, then pass a callback as an argument. We will pass our display function as an argument. So this should display all of the elements in my array to the console. 1, 2, 3, 4, 5. Believe it or not, the element argument is provided for us with the for-each method. Behind the scenes, the for-each method will provide to a callback an element, index, and array argument. An element for the current element that we're on when looping through this array, an index that keeps track of the current index number, and the location of the array itself. In this case, it would be numbers. That's why when we pass the display function as a callback, we're already provided with an element argument behind the scenes. So we're using the for-each method to display all of the elements of this array. Let's use the for-each method again to double each element before displaying it. I will create a new function. Function double to double the value of each element. Element, index, and array are provided for us automatically. For each element, what are we going to do? Let's take our array at index of index. Index keeps track of the current index number. So during each iteration, it's going to increment by 1, starting with 0. We will take our element, multiply it by 2. All right, so let's take our numbers array, use the for-each method, then pass a callback to our double function. So now all of these elements should be doubled. Let's triple them now. We'll create a function for triple. Function triple. We will set the parameters to be the same, but we will multiply each element by 3. Then pass in a callback for triple. So now we have 3, 6, 9, 12, 15. They're all tripled. Let's square each element. Function square. Again, the element, index, and array arguments are provided for us. Take our array that we receive at index of the current index number, set this equal to square a number, we can use the power method of math, then raise a base to a given power. We are raising our base of element to the power of 2. If I pass our square function as a callback to for each, we will now square each number before displaying it. 1, 4, 9, 16, 25. Then this time, let's create a cube function. Function cube. Raise our element to the power of 3. Pass our cube function as a callback to the for each method. And now each number is cubed. 1, 8, 27, 64, 125. Let's create a more practical example. I will create an array of fruits. Let fruits equals some fruit. We have an apple, we have an orange, a banana, and a coconut. We'll create a function to display each element. Function display. It's kind of like what we did before. An element argument is going to be provided to us. During each iteration, let's console.log each element. And then we will use the built-in for each method of our array, fruits. Fruits.forEach. We will pass our function as a callback to display each element of this array. Apple, orange, banana, coconut. Let's create a function to make all of these strings uppercase. Function uppercase. We'll need an element, index, and array. Element, index, array. During each iteration, let's take our array that we receive, add the index of our index, equals, take the element that we receive, use the toUppercase method. So we have an uppercase function that utilizes the toUppercase method. Remember that a method usually belongs to something. This method belongs to the element that we receive. Functions are standalone. Before displaying each element within my array of fruits, let's take our fruits array, use the forEach method, then apply a callback to uppercase to make all of the elements uppercase before displaying them. What I'm going to do is copy all of these elements so they will begin uppercase. I'll create a lowercase function. Function lowercase. We have our element, index, and array. With this line of code, we will use the toLowercase method. Within the forEach method, we will pass our lowercase function as a callback to make all of the elements lowercase. Let's set the elements of our array to be all lowercase again. This will be a challenge round. We will capitalize the first letter in each element of this array. We will create a function, capitalize. The element, index, and array arguments are going to be provided to us. Take our array that we receive, at the current index, set this equal to, we're going to get the first character in each element. We will take our element, get the first character, char at index of 0, method chain to uppercase to make this letter uppercase. Then we will string concatenate our element, use the slice method. We'll create a substring, begin at index 1. This portion is going to create a substring of every character besides the first. The first character we're going to make uppercase. So now this should work. So let's take our capitalize function, pass it to the forEach method, and now the first character in each element is all uppercase. All right, everybody, so that is the forEach method. It's used to iterate over the elements of an array and apply a specified function as a callback to each element. You take your array, use the forEach method, then pass a callback as an argument. It's really useful if you need to apply a function to each element of this array. And well, everybody, that is the forEach method in JavaScript. Hey, it's me again. Today I gotta explain the map method in JavaScript. The map method accepts a callback and applies that function to each element of an array. It's very similar to the forEach method. However, it returns a new array. That's a key difference. For example, let's create an array of constants. I'm picking constants just to demonstrate that we're not changing any elements in this array. We have const numbers. I'll select the numbers 1 through 5 to keep it simple. I will create a function to square each number. Function square. We have one parameter, we have an element. All I'm gonna do is return math.pow. This will raise a base to a given power. We are raising our element to the power of 2, then returning it. We're going to take our array of numbers, use the built-in map method, then pass in our function as a callback. The map method will return a new array. We will create a new array to store the values that are returned. So I will create const squares equals numbers.map. And then let's display our squares. I'll use console.log for now. Console.log our squares. Here are all the numbers squared. 1, 4, 9, 16, 25. Let's create a function to cube these numbers now. We'll copy and paste our square function, but change it to cube. We'll raise our element to the power of 3. Const cubes equals, take our original array numbers, dot, use the map method, pass in a callback to the function we would like to use, cube. Then we will console.log our array of cubes. And we have some new numbers. 1, 8, 27, 64, 125. The map method is very similar to for each, but after completion, the map method returns a new array. We still have our original numbers, whereas in for each, we'll change them. That's a key difference. Let's go over a new example. We'll create an array of students. Const students equals, for my first student, I will pick SpongeBob, then Patrick, Squidward, Sandy. That's good enough. I will create a function to make all of these strings uppercase. Function, uppercase. There is a single element. Remember, the element is going to be provided for us with the map method. Element, index, and array. But we only need element in this case. I will return our element dot to uppercase method. And that's it. We'll create a new array. Students, what can we name this? Students upper, I suppose. We will take our array of students, use the map method, pass in the function we would like to apply as a callback. Then I will console.log students upper. Within my array, all of the students' names are all uppercase. Let's create a function for lowercase. Function lowercase to lowercase. I will create a new array. Const students lower equals the name of the array, students, dot map, pass in our function as a callback. Then display the array of students lower. Now all of the names are now lowercase. All right, third example. This one is more practical. We'll create an array of dates. Const dates equals, certain regions will order their dates differently. For example, you might have the year followed by a month, then a day. We're going to rearrange the order of these dates using the map method. So come up with a few dates. I picked 2024, January 10th. 2025, February 20th. 2026, March 30th. Feel free to rearrange these however you want. I will create a function to format dates. We have one parameter, a single element. Within this function, I will create a temporary array named parts. We're going to split each date into parts and store it within an array within this function. Const parts equals element dot split. We are going to split each element, but where? We are going to split at each dash. For example, with my first element, we'll split this date into 2024, that will be the first element, 1 and 10. Then we'll reformat these parts. I will return a template string. So I'm going to need some placeholders. So $, curly braces. Let's take our array of parts at index of 1. That will be the month. I live in the United States. We arrange our dates with month, then day, then year. I will place my month first. /. Let's include another placeholder. Parts at index of 2. That will be the day of the month. / parts at index 0. That will be the year. We will create a new array. Const formatted dates equals, take our original array, dates, use the map method, then pass the function name as a callback. Then after, I will console.log our formatted dates. And here they are. For me, the dates are now January 10th, 2024, February 2nd, 2025, March 30th, 2026. Feel free to arrange these however you like. Alright everybody, that is the map method. It's very similar to the for-each method. The map method accepts a callback and applies that function to each element of an array. However, it returns a new array when it's finished. That's nice if you need to preserve the original array that the elements came from. And well everybody, that is the map method in JavaScript. Hey again everybody, it's me. Big surprise there. Today I'm going to explain the filter method in JavaScript. The filter method creates a new array by filtering out elements. In this example, we'll create an array of numbers. We will filter out any numbers that are odd. Let's add the numbers 1 through 7. Now we need a function. Function is even. We have one parameter, we have an element that's going to be provided to us by the filter method. We are going to return, then write a condition. We will take our element, modulus 2. The modulus operator gives you the remainder of any division. You can use modulus 2 to check to see if a number is even. If this condition is 0, strictly equal to 0, then we will return true. We will be returning a boolean, true or false. The filter method will take any values that return true and stick them within a new array, which will effectively filter out any elements we don't need that don't return true. Let's see if this works. I will create a new array, even nums equals, take our original array, use the filter method, pass in a callback, is even. We will display console.log our new array, even numbers. And there we are, 2, 4, 6. Let's do this with odd numbers. Function is odd. Take our element, modulus 2. Is this strictly not equal to 0? That means the number is odd. Let's create a new array. Let odd nums equals our original array, numbers, dot, use the filter method, pass in a callback, is odd. Let's check out our new array, odd nums. There we are. We have the numbers 1, 3, 5, 7. Any numbers that are odd. Let's go over another example. I will create an array of ages. I'll use const this time instead of let. Const ages. Pretend we're teaching a college class. We might have some students still in high school. Let's say a student is 16, another is 17, 2 are 18, 19, 20, and then we have somebody that's just a little bit older. They're 60. We'll use the filter method to filter out anybody that is under 18. We will find all of the adults. We will need a function. Function is adult. We have one element as a parameter that's going to be provided to us. We will return a condition. Return, check our element, is it greater than or equal to 18? So that's our function. Let's create a new array of adults equals, take our original array, dot, use the filter method, pass in a callback, is adult. Then display our new array, console.log adults. We have 5 elements. The age of the students is 18, 18, 19, 20, and 60. Let's do this with is children to find anybody that's under 18. Is child function, return element less than 18. We'll create a new array, const children equals, take our original array, use the filter method, pass in a callback, is child, then display the new array. We have 2 students that are children. One is 16, the other is 17. Last example, we'll create an array of words. Const words. Add some words. I think I'll add some fruit. I'll add an apple, orange, banana, kiwi, pomegranate, and a coconut. I will filter out any words where the length of that word is above 6. So we will create a function get short words. We have an element as a parameter. We will return a condition. We will check if our element access the length property of that element. They're strings, so they all have a length property. How many characters are they long? That's the length. Check to see if the length of this element is less than or equal to 6. If it is, return true. If not, return false. We will create a new array. Let's call this array short words equals take our array, use the built-in filter method, pass in a callback, get short words. Then we will console.log the new array. Short words. In our array, there are 4 elements with the length of the characters of each string is 6 or under. Apple, orange, banana, kiwi. Then to finish this off, let's get any long words. We'll create a new function. Get long words. Check the length of the element to see if it's above 6. Then we will create a new array. Const long words equals take our original array, use the filter method, pass in a callback, get long words. Then we will display our new array, long words. Within our original array, there's 2 words that are considered long, pomegranate and coconut. These words each have more than 6 characters. Coconut is 7, pomegranate is 11. All right, everybody, that is the filter method. It creates a new array by filtering out elements. Your callback is likely going to check in condition. Does each element pass this condition? And well, everybody, that is the filter method in JavaScript. What's going on, everybody? So in today's video, I got to explain the reduce method in JavaScript. The reduce method reduces the elements of an array to a single value. In this example, we'll create an array of prices, as if it was a shopping cart. We'll sum all of the prices within our shopping cart and return a total. We'll need an array to work with. Const prices equals an array. Think of some prices, type in anything, as long as it's a number. I'll keep this simple and use whole numbers. I'll add something that is $5, another that is 30, 10, 25, 15, and 20. We will create a variable for a total. Const total equals take our array of prices. We will use the built-in reduce method of arrays, but we do need to pass in a callback to a function. We need to create a function that will sum all of these values. Let's create a function to sum. Our sum function will have 2 parameters. The first will be an accumulator. The second will be the next element. All we're going to do is return our accumulator plus our element. I'll explain how this works momentarily. I just want to be sure that everything runs fine first. Within the reduce method, we'll pass in a callback to the sum function. That will return a single value, a total in this case. Let's see what our total is. Console.log, I'll use a template string, pick a unit of currency, I'll pick American dollars. Add a placeholder, let's display our total. So my total is $105. If you would like to add cents to the end of that, you can follow this with the toFixed method, then add 2 decimal places for cents. Alright, so how does this work exactly? We have 2 parameters, accumulator and element. It might be easier if I were to rename these parameters. You can rename parameters. Let's say accumulator is the previous element. Element is the next element. We're returning the previous element plus the next element. During the first iteration, we'll have 0 and 5. Well, 0 plus 5 would give us 5. 5 is returned to the accumulator. Whatever value is returned becomes the accumulator during the next iteration. So now, our accumulator is 5. The next element is 30. Then we are going to return the accumulator plus 30. which is 35. We'll return this to the accumulator during the next iteration. The accumulator is now 35. The next element is 10. 35 plus 10 would give us 45. Return that to the accumulator and add the next element, 25. So you just follow that pattern. All right, let's go over another example. We'll create an array of grades. Const grades equals, these will be some number grades, 75, 50, 90, 80, 65, and 95. We'll find the maximum value from this array. We'll create a constant to hold to the maximum value. What is the maximum score? Const maximum equals, take our grades array, use the built-in reduce method, then we need to pass in a callback to the reduce method. We need a function to get max. There's two parameters, an accumulator and the next element. Like I said, feel free to rename them. We will return the max method of math. Math.max, pass in these two parameters, accumulator and the next element. Within the reduce method, we'll pass in a callback to get max. The value returned will be the maximum grade from this array. So let's console.log whatever the maximum is. The maximum score from this array is 95. Let's do this with the minimum. Let's copy this function, change any instance of max to min. Get min, math.min. Let's create a new constant, const minimum equals our array of grades. Use the reduce method to return a single value, then pass in a callback to get min. Let's console.log the minimum. The minimum score from this array is 50. Alright everybody, that is the reduce method. It's a built-in method of arrays to reduce the elements of an array to a single value. You can use it to sum the elements of an array. Another possibility is to find the minimum or maximum value from an array. And well everybody, that is the reduce method in JavaScript. Hey everyone, so today I'm going to explain function expressions in JavaScript. A function expression is a way to define functions as a value or a variable, not to be confused with function declarations, where you define a block of reusable code that performs a specific task. We're already familiar with function declarations, such as this. Function, then you create a function name, such as hello in this example. Let's console.log the word hello. With the function expression, we can assign a function to a variable or pass it as a value to another function. So this time, we're going to write a function expression. I will create a constant named hello equals a function, parentheses, curly braces. We'll do the same thing. We will console.log hello. And if I were to run this, the identifier hello has already been declared, so for now I'm just going to remove this function declaration. All we're doing is assigning a function to a variable. To use the function that's stored within, we have to take our variable name and add a set of parentheses to invoke it, kind of like it's a pair of telephones talking to each other. Hello. Using JavaScript, we also have the capability of passing a function as a value. I will introduce the setTimeout function. There's going to be two parameters, a callback to a function, and an amount of time we're going to wait, then execute this function. This will be in milliseconds. 3000 milliseconds translates to 3 seconds. Let me put this function back. After 3000 milliseconds, I will execute the hello function. 1, 2, 3, hello. Instead of using a function declaration, we are going to pass a function expression as an argument to the setTimeout function. Instead of a callback, we will create a function. We will pass an entire function as an argument. What are we going to do? We will, after 3 seconds, console.log the word hello. And let's see if this works, just to prove that I'm not a liar. 1, 2, 3, hello. In JavaScript, it is legal to pass an entire function as an argument or treat it as a value. We'll use previous examples of the map, filter, and reduce methods of arrays. I will create an array const numbers equals the numbers 1 through 6. 1, 2, 3, 4, 5, 6. I would like to square each of these numbers. What we've done in a previous lesson is declare a function square. We had one parameter in that example. We had an element. What we did is we returned math.pow to raise a base to a given power. We're raising our element to the power of 2. The map method will return a new array. Const squares equals numbers.map. We're passing in a callback to square. Then console.log squares. This works. We are using a function declaration. But this time, we will now use a function expression. We will treat this function as a value. Let's cut this function, replace the callback, then paste it within the map method. Then we just need to remove the name. We don't need a name. And this is still gonna work. Yeah, it still does. We don't necessarily need to think of a function name. One of the benefits of doing this is that we're not polluting the global namespace with function names. We're only going to be using this function once. There's no need to declare a function. Let's create a function expression to cube these numbers now. As a beginner, it might be helpful to write out your functions as a declaration first, then transform it into a function expression. Function cube. We have our element as a parameter. I'm going to copy this. Return math.pow element to the power of 3. We will create a new array. Const cubes equals numbers.map. We don't need to pass in a callback. We will cut this entire function, paste it within the map method. Then we don't need the name. Then console.log cubes. There are all the original numbers cubed. All right, I think we're starting to get the hang of this. Let's quickly use the filter method to filter out any even or odd numbers. I will create const even nums equals take our array numbers. We will use the filter method. Then we will pass a function expression as an argument. There's one parameter, an element. We are going to return element modulus 2 to see if it's divisible by 0. Is the result strictly equal to 0? Let's see if this works. Console.log even nums. There they are. We have 2, 4, 6. Let's do this with odd numbers. Odd nums. Use the filter method again. All we're going to change is strictly not equal to 0. Return any odd numbers. 1, 3, 5. Then lastly, reduce. We will sum all of the elements of this array. Const total equals our numbers dot reduce. Pass in a function expression. We have two parameters, an accumulator and an element. We will return accumulator plus our element. Return the total, which is 21. We already do have some practice with map, filter, and reduce. Instead of using function declarations, then passing a callback, we can pass an entire function expression as an argument to these methods. In the next topic, I'll discuss arrow functions, which shortens the syntax even further. You'll like arrow functions. Alright everybody, so those are function expressions. They're a way to define functions as a value or a variable. We've both defined a function expression as a variable. We stored that within this hello variable. We've also passed entire functions as an argument, which you can do with JavaScript. There's a few benefits of function expressions, one of which is you don't need to keep on thinking of function names. You can perform a function once, then just forget about it. They're also used in callbacks and asynchronous operations, higher order functions, closures, and event listeners. These are topics we still need to discuss, but we will be using function expressions a lot. Don't worry, we will have more practice. And well, everybody, those are function expressions in JavaScript. Hey, hello there. So today I'm going to explain arrow functions in JavaScript. An arrow function is a concise way to write a function expression. It's good for simple functions that you only use once. Here's the formula. You have your parameters, arrow, then some code you would like to perform. Here's an example. Suppose I have a function declaration. I have the hello function. All we're going to do is console.log the word hello. To use this function, I need to call it by its name, add a set of parentheses. This will display the word hello. A concise way to write the same function is to use an arrow function. We'll begin with a function expression, then convert it to an arrow function, just so we understand the differences. This time, I will create a constant, hello. Hello is going to be a constant that stores our function expression. If I were using a function expression, we would say function, parentheses, curly braces, then the code we want to perform. Console.log the word hello. This would do the same thing. Hello. A more concise way to write this function expression would be to use an arrow function. Following this formula, we list our parameters. We don't have any. We need a set of parentheses, arrow, then some code we would like to perform. I'm going to console.log the word hello. And that works. We're sticking an arrow function within a variable or named constant. To invoke the arrow function within, we just follow that constant or variable with a set of parentheses like we're calling it, as if it's a pair of telephones talking to each other. You can send some arguments to an arrow function. We'll need to set up the parameters. I will have a name parameter. Within our code, let's console.log. I'll use a template string, hello, add a placeholder, add my name parameter. Now I need to pass in an argument because right now it's hello, undefined. Pass in your first name as an argument. Hello, bro. Within your code, if you need to include more than one statement, you'll need to enclose all of that code within a set of curly braces. Let's add a new line. Console.log you are old. Hello, bro, you are old. Okay, let's set up another parameter. This time, we will accept an age argument. Let's transform our second console.log to be you are, add a placeholder, our parameter age, years old. Now we'll pass in a second argument for age. Hello, bro, you are 25 years old. So that's the basics of an arrow function. You have your parameters, arrow, then some code you would like to perform. There's no need to create a function declaration. Let's go over another example. We have the set timeout function. This function accepts a callback, then a given amount of time we are then going to execute this code, this callback. After 3 seconds, 3000 milliseconds, I will execute whatever this callback is. Let's create a function to say hello again. Function, hello. We will console.log the word hello. I will pass in a callback. After 3 seconds, we say hello. In place of a callback, I could use a function expression. Let's cut our function. Remove this argument, then paste our function expression. Remember, we don't need the name for a function expression. This works as well. Hello. Or otherwise, we can use a more concise arrow function. We will pass that as an argument. We have our parameters, we don't have any, arrow, then some code. Console.log the word hello. After 3 seconds, we display the word hello. Now we'll use arrow functions with map, filter, and reduce. We have an array of numbers. Const numbers equals the numbers 1 through 6. Let's start with using the map filter to square each of these numbers. But we will use arrow functions. Const squares equals our original array numbers dot map. Normally, we would pass in a callback as an argument, but we're not going to do that. We'll use an arrow function. We have one parameter, an element, arrow, take each element, use math.pow to raise our element to a given power. Then let's console.log our squares. Console.log squares. There they are. Here are all the original numbers squared. 1, 4, 9, 16, 25, 36. Let's cube each number. Const cubes raise our element to the power of 3. Console.log our cubes. There are all the numbers cubed. We'll use the filter method to filter out any numbers that are odd. Const even nums equals our array numbers. We will use the filter method. We can pass in a callback, but we don't need to. We will pass in an arrow function. We have our element as a parameter, arrow. We don't necessarily need a return statement if we have only one line of code. Take our element, modulus 2, is it divisible by 2? And does this strictly equal 0? If it does, it's an even number. Let's console.log our even numbers. 2, 4, 6. Let's do this with odd numbers. Odd nums. Take our element, modulus 2, is it strictly not equal to 0? Display our odd nums. 1, 3, 5. And lastly, let's do reduce. We will get a total by summing all of the elements of this array. Const total equals our original array dot reduce, pass in a callback or an arrow function. This time we have two arguments, an accumulator and an element. We have an arrow, return our accumulator plus our element, then display the total. Our total is 21. Alright everybody, so those are arrow functions. They're a concise way to write a function expression. They're good for simple functions that you only use once. You list your parameters within a set of parentheses, an arrow, then some code you would like to perform. In this example, we've written a more concise way to use the map, filter, and reduce methods. Normally, we can pass in a callback as an argument, a function expression, or an arrow function. And well, everybody, those are arrow functions in JavaScript. Hey, what's going on, everybody? In today's video, I'm going to discuss objects in JavaScript. An object is a collection of related properties and/or methods. Properties are things that an object has, such as a first name or an age. A method is a function that belongs to an object. For example, I have a person object. Our person can say hello, and they can say bye. Methods are just functions that belong to an object. What can this object do? Objects can represent real-world objects, such as people, products, or places. In this example, we'll be creating some people objects. People from the show SpongeBob. We'll start from scratch, though. We'll create a person object. I'll use a constant, although it's not necessary. Const person equals, then add a set of curly braces. We'll start with any properties. You can add as many properties as you would like. They're in key value pairs. This person will have a first name key, colon, then some value. This person's first name will be SpongeBob. Separate each key value pair with a comma. Let's include a last name property. Last name, colon, space, will be SquarePants. Add a comma when you're done with this key value pair. We'll add an age property of 30. Age has a different data type. It's a number. The first two in my example were both strings, SpongeBob and SquarePants. Let's add a boolean. Is employed, colon, space, I will set that to be true. He has a job at the Krusty Krab. Okay, that's good enough for now. I would like to access these properties. Let's console.log. If I need one of these properties, take the object you're referring to, in this case person, dot the name of the property. Let's do first name. Person.firstName property. That would give me SpongeBob. Let's do this with last name. Take the object name, dot the name of the property. Person.lastname is SquarePants. Let's do this with age. Person.age is 30. Person.isEmployed is set to true. All right, let's create another object. We'll create an object for Patrick. Const person. Now, objects can't have the same name. Objects need different names. For example, I can't have two person objects. They can't have the same name. Syntax error. Identifier person has already been declared. I will rename our first person as person1. Our second person will be person2. Then any place in which I'm referencing person will now need to be person1. Let's reuse these same key value pairs. Person2's first name will be Patrick. His last name will be Star. Patrick will be, I don't know how old he is according to the TV series, let's say he's 42. Is Patrick employed? No. He just watches TV all day. Now I would like to access person2's properties. Okay, we'll console.log person2's first name, person2's last name, person2's age, person2 is employed. Okay, for person2 we have Patrick, Star, 42, false. So those are properties of an object. They're key value pairs. Add as many as you would like. In this example, these properties mimic real-world attributes that a person might have, like a first name, last name, age, whatever you can think of. But not only that, objects can have dedicated functions that we refer to as methods. What sorts of actions can these objects perform? For example, a person could eat, they could drink, they could sleep. What sorts of things do people do? So just to keep this simple, I am going to create a function to say hello. We'll start with person1. Say hello, colon space. This will be a function expression. What are we going to do? When we invoke this function, let's console.log. What would SpongeBob say if he's greeting somebody? Hi, I'm SpongeBob. Be sure you're not including a semicolon at the end. That should work. Let's test it. I'm going to have person1 invoke their say hello method. Hi, I'm SpongeBob. Let's add a say hello method to Patrick, person2. We'll change the output of say hello. What would Patrick say? Hey, I'm Patrick, ... Now we'll have person2 use their say hello method. Hey, I'm Patrick. You can add as many methods as you would like. So with these functions, we're using a function expression. If you prefer, you could even use an arrow function. List your arguments, arrow, then the code you would like to perform. This would work too. Let's add an eat method. Eat function. We'll use a function expression for SpongeBob. Let's console.log. What is SpongeBob eating? I am eating a Krabby Patty. We'll include an eat function for Patrick as well. What's Patrick gonna eat? Patrick is eating... I am eating roast beef, chicken, and pizza. And if you would like, you can use an arrow function for this example. List your parameters, arrow, then the code you would like to perform. It's not necessary, but I do like arrow functions. Person1, SpongeBob, will use his eat method. Same thing goes with Patrick, person2. So SpongeBob is eating a Krabby Patty. Patrick is eating roast beef, chicken, and pizza. Alright everybody, so JavaScript objects are a collection of related properties and/or methods. Properties are what an object has. Methods are functions that an object can perform. They can represent real-world objects such as people, products, or places. Properties are key-value pairs. Methods are functions that belong to an object. And well, everybody, that is an introduction to object-oriented programming in JavaScript. Hey, so we gotta talk about this. This is a keyword. It's a reference to the object where this is used. The object depends on the immediate context. If we had a person object, and we're accessing their name property, we could replace person with this. As long as we're within the context of that person object, we'll create an object, const person1. Let's add a property for name. The name will be SpongeBob. And a favorite food property, fav food. SpongeBob likes hamburgers, more specifically Krabby Patties. I will give SpongeBob a say hello method. This will be a function. All we're going to do is console.log. I'll use a template string. Hi, I am. I'll use a placeholder. Let's attempt to use person1's name. Let's see what happens. Let's take our object of person1. I will invoke their say hello method. Let's see what happens. Hello, I am, and there's nothing here for the name. Inside of this object of person1, if I would like to access one of these properties, I'm gonna precede the property with this. This dot the name of the property. And that should work. Hi, I'm SpongeBob. We're using this within the context of person1. It would be like us saying person1.name. There would be no difference. This is a reference to the object we're within. If I said this dot favorite food, well, fav food for short, hi, I am hamburgers. It would be like us saying person1.fav food. Let's add another method. I will add an eat method. Let's console.log. I'll use another template string. Add a placeholder. This dot name is eating. Add another placeholder. This dot fav food. Let's have person1 use their eat method. SpongeBob is eating hamburgers. The cool thing about this keyword is that if we create a new object with these same methods, we'll use the second object's properties. Let's copy person1, paste, change person1 to person2. The name for person2 will be Patrick. Favorite food will be pizza. Let's have person2 use their eat method. SpongeBob is eating hamburgers. Patrick is eating pizza. Since we're in the context of person2 now, imagine we're replacing this with person2. Person2.name, person2.favfood. If you were to use this outside of any objects, I'm going to console.log this. What we're returned with is a window object. Basically, we're returning the window to see our website. Technically, we're inside of an object already, our window object. And we have all of these properties. But since we're using this keyword inside the context of person1 and person2, we'll instead make a reference to those objects. Hey, one thing I forgot to mention, this keyword doesn't work with arrow functions. For example, with person2, let's convert this to an arrow function. Blank is eating undefined. When you use this within an arrow function, it's making a reference to that window object still. Our window object does have a name, that's why it's appearing empty, but fav food is undefined because our window object doesn't have a favorite food property. Alright everybody, so that is this keyword. We will be using this keyword a lot. All it is a reference to the object where this is used. And that is this keyword in JavaScript. What's up, people? So today I gotta explain constructors in JavaScript. A constructor is a special method for defining the properties and methods of objects. In prior videos, we've constructed objects like this. We would declare an object, assign it some properties, and some methods. You know, this works, but what if we have to create a lot of objects? Here I'm manually creating 3 different car objects. That can be a lot of work. What we could do instead is use a constructor to construct these objects automatically. All we have to do to construct these objects is pass in some unique data to the constructor to construct these objects. Here's an example. We are going to create a function, car. Do pay attention to the capitalization. We'll need to set up some parameters. What sorts of properties will we accept when we construct a car object? How about a make, model, year, and color? These are arguments we'll receive when we construct a car object. To assign these properties, we're going to use the this keyword dot make equals the make that we receive. Let's do this with model. This dot model equals the model we receive. This dot year equals year. This dot color equals color. That's good enough for now. Our car constructor is a reusable method where we can define the properties and methods of objects we create. To use this constructor, I will create an instance of an object. I will use const. Car1 will be our first object. Equals, we'll need to use the new keyword. Type the name of the constructor, car. Car is a special method. We'll need to pass in some arguments. We'll need a make, model, year, and color in that order. My first car, feel free to send some different data to the constructor, but for me, my first car will be a Ford. Make sure each value is comma separated. Mustang. The year will be 2024. And the color will be red. We should now have a car object with the name of car1. And I'm going to console.log car1's properties. car1.make Ford. Let's do this with the other properties. We have model, Mustang, year, 2024, and color, red. Now, this method is reusable. We can reuse it to create other car objects. Let's create const car2 equals new car. We'll pass in different data this time. The make will be Chevrolet. I will pick a Camaro. The year 2025. And the color will be blue. Now I can display car2's properties. Let's select car2.make, car2.model, car2.year, car2.color. We have a Chevy Camaro, year 2025. The color is blue. Let's create one more car. Same process as before. Const car3 equals new car. I'll go with a Dodge Charger, the year 2026, and the color will be silver. Let's access car3's properties. car3.make, car3.model, car3.year, car3.color. Dodge Charger 2026, the color is silver. Another thing with these parameters too, you can name these parameters anything. When we assign these properties, it can be kind of confusing. Like this.make equals make. Really, we write our constructors this way just for readability. Technically, this would work if we renamed our parameters. For example, make will be parameter A, model will be B, year is C, color is D. Then be sure to change these when we assign them. A, B, C, D. This would still work. However, this constructor isn't as readable. Like, what the heck is A, B, C, and D? It would be good practice to clearly define our parameters for readability purposes. All right, now let's add a method. We'll take this dot drive equals a function. We'll console.log. I'll use a template string. You drive the, I'll add a placeholder, this dot model. With cars 1 through 3, let's use the drive method. Car1.drive. You drive the Mustang. car2.drive, you drive the Camaro, and car3.drive, you drive the Charger. Alright everybody, so that's a constructor. It's a special method for defining the properties and methods of objects. It helps with code reusability. We can reuse it to create many objects, instead of having to type them all out manually. And well everybody, those are constructors in JavaScript. Alright, let's do this thing. So I gotta talk about classes in JavaScript. Classes are an ES6 feature that provides a more structured and cleaner way to work with objects, compared to the traditional constructor functions that we're normally used to. Classes are going to be really helpful when we reach future topics such as the static keyword, encapsulation, and inheritance. In this example, I have a constructor for a product. Our product needs a name and a price. For example, we have a shirt, and the price is $19.99. Instead of using a constructor method, we're instead going to use a class. Our class will include a constructor. So let's start from the beginning. To create a class, you type class, then the name of the object. So our class is going to serve as a blueprint. Our objects will be products. Then add a set of curly braces. To use a constructor, we can use the constructor keyword within our class. List any parameters. We will have a name and a price for each product. We will assign the properties of this.name equals the name parameter that we receive. This.price equals price. I will also create a function. Our function will be display product. Now inside of a class, you don't need to use the function keyword. When we would like to display this product, we will console.log product : space, I'll include a placeholder, this.name. Let's also output the price. Price, pick a unit of currency, I'll use American dollars, this.price. Let's create some product objects. Const product1 equals, to create a new object, we have to use that new keyword, the name of the class, product. The constructor is going to be called automatically, but we do need to pass in a name and a price as arguments. We will pass in a shirt. The price will be $19.99. Just to be sure that everything works, let's invoke the display product method. Product1 dot display product method. Here are the details of our product object. Product shirt, price $19.99. Let's create a few more. So this class is reusable. Product2 will be pants. I'll pick $22.50 for the price. Let's display product2, and we will use the display product method of our class. Product pants, the price is $22.50. Looks like I only have one decimal point. I'm going to make one change. After the price, I will use the toFixed method and set this to be 2 decimals. There, $22.50. All right, product 3. Const product 3 equals new product. Our third product is going to be underwear. This underwear is really expensive. It's $100. It's really good underwear, guys. Product 3 dot display product underwear, price $100. Here's a challenge round. I'm going to add another method. This method will have one parameter, sales tax. We'll create a method to calculate a total including tax. So let's create a new method. Inside of a class, we don't need the function keyword. Calculate total. There will be one parameter, sales tax. All we're going to do is return this.price plus, to calculate the sales tax, we'll take this.price times the sales tax, assuming it's a percentage. Okay, let's display product1 dot display product. I'm also going to create a constant for the sales tax. That's not going to change. Const sales tax. Let's say the sales tax is 5%, 0.05. I will create a variable const total equals, let's take product 1, use the calculate total method, but we have to pass in sales tax. We can either pass in this number or this variable. Once we have our total, let's display it. Console.log, I'll use a template string, total price, in parentheses, with tax. I'll add a placeholder, display the total, pick a unit of currency, I'll use American dollars, then I'll add 2 fixed 2 to set it to 2 decimal places. Alright, our product is a shirt, price is $19.99, total price with tax is $20.99. Let's do this with product 2. Product 2.display product, product 2.calculate total. Pants $22.50, total price $23.63. Let's check out our really expensive underwear. Product 3.display product, product 3.calculate total. Our underwear is $100, including sales tax, it's $105. Alright everybody, so those are classes. They're an ES6 feature that provide a more structured and cleaner way to work with objects, compared to the traditional constructor functions that we learned about in the last video. Classes are going to be really helpful with a few upcoming topics. And well everybody, those are classes in JavaScript. Hey people, let's do this thing. So the static keyword. Static is a keyword that defines properties or methods that belong to a class itself rather than the objects created from that class. In summary, a class owns anything static, not the objects. So what we're going to do is create a class for math utilities. Class math util for short. We'll create our own version of pi. We'll use the static keyword. The name will be pi. Pi will equal 3.14159, just the first few digits. I'm going to zoom in a little. If I would like the static property, I have to access it by its class. So let's console.log, the name of the class, math util dot the name of the property, pi. Our static property is 3.14159. I don't need to create an object in order to use this property. I don't have to type const math util1 equals new math util. I would have to type math util1, that's the name of this object, in order to access pi. All I have to do is type the name of the class. And that's pretty convenient. Anything declared as static belongs to the class itself, and not any object created from that class. So now we're going to create a static method. We'll use the static keyword. We'll get a diameter once we pass in a radius as an argument. Get diameter. We have one parameter, a radius. All we're going to do is return radius times 2. Okay, let's console.log. Again, we have to type the name of the class, math util. Dot the name of the method. Get diameter. We have to pass in a radius though. Let's pass in 10. Our diameter is 20. Let's create a new static method for get circumference. Get circumference. The formula is going to be, we will be returning 2 times this, meaning math util, dot pi times the radius we receive. Let's console.log. Let me make the C capital. The name of the class, math util dot get circumference. Pass in a radius. The circumference is 62.83. Let's create one more for get area. Static get area. We need a radius. We will return this dot pi times radius. So that's radius squared. Console.log, math util, the name of the class, get area. pass in 10, and the area is 314.15. In the next example, we'll have a mix of regular properties and methods and static properties and methods. This will be example 2. We'll create a class of users. Class user. We'll create a static variable to keep track of the amount of users we create. User count. I will set that equal to 0. I'll include a constructor. Let me just space this out a little. Our constructor is going to be automatically called when we instantiate a new object. We need one argument, though, when we create a new user. We need a username. Once we have our username, we will assign this dot username equals username. Not only that, but when we create a new user, I'm going to increase our user count by 1, just so we can keep track of how many users we create. So inside of the constructor, you can write additional code. It's not only for assigning properties. Let's take user dot user count plus plus to increment it. Let's create some user objects. Const user1 equals new user. Pass in a username. I'll pass in SpongeBob. Then let's console.log user1's username, which is SpongeBob. Let's attempt to access user1's user count. With user1's user count, we get undefined. That's because our user doesn't have user count as a property. It's static. That means it belongs to the class, not any objects created from the class. To access user count, we have to type the name of the class. User in this case. We have one user. Let's see what happens when I create a new user object. User2 will equal Patrick. Our user count is now 2. Let's display user2's name. Yep, we have SpongeBob and Patrick. The total user count is 2. Let's create a third user. User3 will be Sandy. Console.log user3.username. Our user count is now 3. We have a static property that's keeping track of the amount of users we create. Let's create a method. The first one will not be static. Say hello. All we're going to do is console.log. I'll use a template string. Hello. My username is, I'll add a placeholder, this.username. Let's have user1 use their say hello method. Same thing with user2 and user3. Hello, my username is SpongeBob, Patrick, and Sandy. Now we'll create a static method. We'll get the user count. Get user count console.log. I'll use a template string. There are, I'll add a placeholder, user.userCount, users online. Now, in order to access this method, I have to type the name of the class. User.getUserCount. Oops, and I can't console.log that. User.getUserCount. There are 3 users online. Alright everybody, so that is the static keyword. It defines properties and methods that belong to a class itself rather than any objects created from that class. In summary, the class owns anything static, not the objects. And well, that is the static keyword in JavaScript. Hey, what's up everybody? So in today's video, I gotta explain inheritance. Inheritance allows a new class to inherit properties and methods from an existing class. These two classes have a parent-child relationship. A child will inherit properties and methods from a parent. It's kind of like a family tree. A child will inherit genes from a parent. Inheritance helps with code reusability because we don't need to keep on repeating the same properties and methods if all the children share them. Here's an example. We'll create an animal class. Class animal. We'll have a property of alive. If you're an animal, you start off being alive. All animals should be able to eat and sleep. We'll create methods for those. We'll have an eat method. All we're going to do is console.log. I'll use a template string. This. Now I'll add a placeholder. This dot name is eating. And a sleep method. Sleep. This dot name is sleeping. Animal will be the parent class. We'll create children classes that inherit these properties and methods. Let's create a few children classes. Class rabbit. Our rabbit class will inherit all the properties and methods of the animal class. To declare a parent-child relationship, the child will extends the parent, animal. For the rabbit, I'm going to give this class a name. Name equals rabbit. This will be a property. If you're familiar with the static keyword, you can make the static. Now we'll create a fish class that also extends animal. Class fish extends animal. Fish will have one property. Name equals fish. And a hawk class. Class hawk extends animal. We'll have one name property. Hawk. Alright, let's see if this works. If we create a rabbit, fish, and hawk object, they should have access to these properties and methods. Let's create const rabbit equals new rabbit. Const fish equals new fish. Const hawk equals new hawk. All right, let's see if our rabbit has an alive property. Console.log. Take the name of the object, rabbit, dot, access a property or method. Alive, that's our property. The rabbit is alive. But what if the hawk swoops in and kills the rabbit? Let's change the alive property of the rabbit. Rabbit.alive equals false. The rabbit is no longer alive. Now let's see if our rabbit has access to a eat and sleep method. Rabbit.eat. This rabbit is eating. And sleep. Rabbit.sleep. The rabbit is sleeping. Let's test this with fish. Fish.alive, fish.eat method, fish.sleep method. The fish is alive, the fish is eating, the fish is sleeping. And hawk. Hawk.alive, hawk.eat method, hawk.sleep method. The hawk is alive, the hawk is eating, the hawk is sleeping. Our children classes of rabbit, fish, and hawk all inherited the properties and methods of the parent animal class. This helps with code reusability, because I don't need to declare all of these properties and methods within each of the children classes like this. We're saving a lot of lines of code. It's not that apparent with just a few child classes, but imagine if you had hundreds of different child classes. Well, by using inheritance, you would be saving a lot of time. But not only that, the children can have their own unique properties and methods too. For example, rabbits will be able to run, but fish and hawks can't run. That's a method that only belongs to rabbits. Within our rabbit class, let's create a new method, a run method. We'll console.log. I'll use a template string. This, add a placeholder, this.name is running. Within our fish class, let's create a swim method. Swim. This.name is swimming. And hawks will be able to fly. We'll create a fly method. This.name is flying. Let's minimize these classes. Let's take our rabbit object, display the alive property, the eat method, the sleep method, and the run method. Rabbit.run method. The rabbit is eating, the rabbit is sleeping, the rabbit is running. Now let's do this with fish. Fish.alive, fish.eat method, fish.sleep method. Now, does the fish have a run method? It does not. Fish.run is not a function. Run is a method that belongs to the rabbit class. Fish can't run because, well, they don't have legs. We did not give our fish class a run method. They can swim, though, but they can't run. Fish.swim method. The fish is swimming. Let's do this with hawk. Our hawk cannot swim, but it can fly. We'll use the fly method. The hawk is eating, the hawk is sleeping, the hawk is flying. And of course, our rabbit can't fly or swim. Does our rabbit have a fly method? It does not. Rabbit.fly is not a function. Alright everybody, so that's inheritance. It allows a new class to inherit properties and methods from an existing class. A child inherits properties and methods from a parent. It helps with code reusability. I don't need to declare all of these properties and methods for each of these classes. I can simply reuse it. That helps us follow the dry principle. Don't repeat yourself. And well everybody, that is an introduction to inheritance in JavaScript. Yo, what's going on everybody? So in today's video, I'm going to explain the super keyword in JavaScript. Super is a keyword that's used in classes to call the constructor or access the properties and methods of a parent. The parent is also known as the superclass. It's very similar to the this keyword. This refers to this object. Super refers to the parent of that object. Here's an example. We'll use inheritance to create a parent class of animal. Class animal. Our animal class will have 3 children, also known as subclasses. Class rabbit extends animal. Class fish extends animal. Class hawk extends animal. We'll add an empty constructor for now for the animal class. Then we need a constructor for the rabbit class. So rabbits, they'll have a name property, age, and a run speed. We'll assign these properties within the constructor. This.name equals the name that we receive. This.age equals age. This.runSpeed equals run speed. Let's copy this constructor. Now with fish, fish don't have a run speed, but they'll have a swim speed. Let's replace run speed with swim speed. Copy the constructor again, paste it. Hawks in this example won't have a swim speed. They'll have a fly speed though. Replace swim speed with fly speed. Now let's attempt to create some of these objects. Const rabbit equals new rabbit. We need a name for this rabbit. You could just say rabbit, or if you want to be creative, you could say something like Bugs Bunny. But let's just stick with rabbit to keep it simple. Our rabbit will be 1 year old and has a run speed of 25 miles per hour. If you use kilometers, feel free to use kilometers. Let's do this with fish. Const fish equals new fish. The name of our fish will be fish. Our fish is 2 years old and has a swim speed of 12 miles per hour. Then with hawk, const hawk equals new hawk. Our hawk will have a name of hawk. Our hawk will be 3 years old and has a fly speed of 50 miles per hour. So when I run this program, we have an uncaught reference error. Must call superconstructor in derived class before accessing the this keyword. So what JavaScript is telling us is that before we can use the this keyword, we have to call the constructor of the parent, the superclass. Within each of these respective constructors, we will invoke the constructor of the parent, the superclass, with the super keyword. So let's do that for each of these constructors. Now our program actually runs now. So one of the benefits of using constructors is that if there's any properties that the children all share in common, we can send them to the constructor of the parent. As you can see, we're repeating ourselves a lot. Each of these children classes has a name and age property that we're assigning to each. We would like to follow the dry principle. Don't repeat yourself. So why don't we write this code once and reuse it? So within the constructor of the parent, we'll accept a name and age property. We'll assign this.name equals name, and this.age equals age. Now we can remove that within each of the child classes so we don't repeat ourselves. There's less code to write now, but we do need to pass in these arguments to the parent constructor, name and age for each. And that's all there is to it. In this example, when we construct an object, either a rabbit, a fish, or a hawk, we'll accept 3 arguments, a name, age, and either a run speed, a swim speed, or a fly speed depending on the animal that we're creating. Any properties they share in common, we can send to the parent constructor. It helps with code reusability, and there's a lot less to write. It's not that evident with 3 children classes, but imagine if you had hundreds of different classes. Like, what if this was Pokemon? There's like, what, 1,000 Pokemon now? We would have to copy and paste those properties like 1,000 times for each, if we're constructing individual Pokemon. But since all of them share those same properties, we can write it in one place, and make any changes only in one place. So let's test this to see if it works. Let's console.log our rabbit's name, which is named Rabbit. Let's console.log the rabbit's age. The rabbit is 1 year old. And let's see if the rabbit has a run speed. 25, as in 25 miles per hour. Let's do this with fish, fish.name, fish.age. Let's see if the fish has a run speed. Name is fish, age 2. Run speed is undefined because fish can't run because they don't have legs, but they do have a swim speed though. Swim speed, 12 miles per hour. Then hawk. Hawk.name, hawk.age, hawk.fly speed. Name is hawk, age 3. The hawk has a fly speed of 50 miles per hour. So that's how you can use the super keyword in a class to call the constructor of the parent. It helps with code reusability. Any properties that the children share in common, in this case a name and age, the constructor of the parent can take care of that. We don't have to repeat the set of code every single time for each child. We write it in one place and reuse it. Another thing you can do too with the super keyword is extend a method from the parent. So what we're going to do within the animal parent class is create a move method. Within this method, we will console.log the following message. The, add a placeholder, this.name moves at a speed of, add a placeholder, speed, mph for miles per hour, or if you prefer, you can use kilometers. Our move method will have one parameter, a speed that we need to pass in to use. So within each of these children classes, we'll write a method that also extends the move method of the parent. Rabbits will have a run method. We'll output the following message. Console.log. I'll use a template string. This, add a placeholder, this.name, can run. Let's copy our run method, paste it for fish, but change swim to run because fish can't run. This.name can swim. Then with hawks, they'll have a fly method. Fly, this.name can fly. With our rabbit object, let's invoke the run method. This rabbit can run. Let's do this with fish. Fish.swim. This fish can swim. And hawk.fly method. This hawk can fly. Within each of these children classes, we're going to extend the move method of the parent animal. Within the run method of our rabbit class, not only are we going to output this message, we'll also extend the move method of the parent and display that message as well. To refer to the parent class, we use the super keyword. It's very similar to this, but it means the parent. Use the parent's move method. But we do have to send a speed argument. Let's send the run speed of the rabbit, this.runSpeed. Let's do this with our fish class. We'll extend the move method, super.move, send in this.swim speed, and hawk, super.move this.fly speed. Now let's take our rabbit, use the run method, and we should extend the move method. This rabbit can run. The rabbit moves at a speed of 25 miles per hour. Let's do this with fish, fish.swim. The fish can swim. The fish moves at a speed of 12 miles per hour. And hawk, hawk.fly method. This hawk can fly. The hawk moves at a speed of 50 miles per hour. So that's how you can use the super keyword to extend a method of a parent. Alright everybody, so that's the super keyword. It's a reference to a parent. It can be used to call the constructor of a parent and or access the properties and methods of a parent. And well everybody, that is the super keyword in JavaScript. Hey, hello. So today I'm going to explain getters and setters in JavaScript. Getters are special methods that make a property readable. Setters are special methods that make a property writable. We can use getters and setters to validate and modify a value when reading or writing a property. It helps with validation when creating an object or updating one of its properties. Here's an example. We will create a class of rectangle. We need a constructor. We will have two parameters, a width and a height. We will assign this.width equals width, this.height equals height. Now let's create a rectangle object. Const rectangle equals a new rectangle. For the width, let's say -1 million, something ridiculous. And for the height, I want the height to be pizza, the word pizza. Then let's console.log our rectangle's width and the rectangle's height. We have created a rectangle object with the width of -1 million and a height of pizza, which doesn't make any sense. We could use some validation when creating an object. We don't want people to enter in garbage values like -1 million or string when we're expecting a positive number for the width or height. That's where getters and setters come in. We'll begin with setters. When setting one of these properties, either initially through a constructor or updating one of them later, such as setting the width or height equal to some value, we can go through a setter first. Outside of our constructor, we will set a property. We'll begin with width. This will be a special type of method. The parameter will be new width. What do we want to check before assigning this property? Using an if statement, let's check to see if the new width that the user sends us is greater than 0. If it is, we will assign this._width. Using an underscore prefix, it tells other developers that this is a private property. You shouldn't touch it at all. You could say that this private property of width is different than our standard width property. We will assign the private property of width equal to the new width we receive. Else, let's console.error, not log, we'll use error this time. Width must be a positive number. Alright, let's see what happens. Width must be a positive number, and our width is currently undefined, which is good. Okay, let's do this with height. Let's copy our setter for width, paste it, but change every instance of width to be height. Set height, new height. Be sure to use that camel case naming convention. If new height is greater than 0, assign the private property of height equal to the new height. Else, console.error, height must be a positive number. And there we go, that worked. Width must be a positive number, and height must be a positive number. Our width and height are currently undefined. In order to set the width and height, we have to pass in a positive number. For the width, I will say 3. For the width, 4. Now when we access width and height, those numbers still aren't showing up. That's because these properties are writable via setters, but they're not readable. That's where getters come in. We'll create 2 getters. One for width. We'll need to use the get keyword, get width. This will be another type of method. All we're going to do is return this private width. And that appeared to work. We have 3 for the width. Let's do so with the height. We will return this private height. We have 3 and 4. Now by using setters, we can even update those values later. Let's take our rectangles, width, set that equal to be 5. Take the height, set it equal to be 6. And that also appears to work. But again, if I try and update those values to some garbage values like -1,000,000 and the word pizza, we get those errors again. And our object retains its initial values that we previously assigned it, 3 and 4. With getters, we can even use the property accessor, that dot, to access a property that doesn't necessarily exist. For example, we will get area. We'll perform a calculation. We will return this private width times this private height. So now we can access area as if it was a property. We have 3 for the width, height 4. Our width times our height gives us an area of 12. Our area isn't a property technically. It's not found within our constructor. But we can access it as if it was a property with a getter. With getters, you can even add additional logic. I would like to preserve the initial values of our width and height. When I return their value, I will use the toFixed method to give each of these a precision of 1. Let's do that with the width, the height, and the area. But that's going to be a little more complex. We'll enclose width times height, then add toFixed 1. And why stop there? I'll add centimeters to the end of each. I'll use a template string, add a placeholder, then add cm for centimeters, 3.0 cm, and the area. 12.0 centimeters. Let's make that centimeters squared because it's area technically. When you're assigning values, even when you're initially creating an object, you can go through the setters for input validation. When you retrieve values and try and read them, you can add additional logic too. Let's go over a second example. We will create a class of person. We need a constructor. We will accept a first name, last name, and an age. This dot first name equals first name. This dot last name equals last name. This dot age equals age. Let's construct a person. Const person equals new person. Let's enter in some values that don't make sense. The person's first name will be the number 420. Their last name is the number 69. Their age is the word pizza. Let's console.log our person object's first name, which is the number 420. Their last name, 69, and their age, the word pizza. We need to validate this input before assigning the properties. That's why we need setters. We will set the first name property. This is a special type of method. The parameter is going to be a new first name. We need to be sure that this value passed in is a string and the length is greater than 0. We could write something like this. We need an if statement. Let's check the type of our new first name? Is it strictly equal to a string? And is our new first name's length property greater than 0? If all of that checks out, we will assign this private first name equal to the new first name we receive. Else, let's console.error first name must be a non-empty string. Let's see if this worked. I'm going to save. First name must be a non-empty string, and currently our first name is undefined. Okay, that worked. Let's copy our setter for our first name, paste it, change every instance of first name to last name. New last name. Check if the type of our last name is equal to a string, and if our new last name, the length of it, is greater than 0. If it is, assign the private last name property equal to the new last name. Else, last name must be a non-empty string. That also worked. Our first name and last name are undefined. Let's do this with age. Set our age. The parameter is going to be new age. Using an if statement, is the type of new age strictly equal to a data type of number? And is our new age greater than or equal to 0? If it is, take this private age equals our new age. Else, we're going to console.error age must be a non-negative number. We can no longer assign pizza for our age, unfortunately. All right, we have our setter set up. Now let's work on the getters. Let's assign some legitimate values. For the first name, SpongeBob. Last name, SquarePants. Age, 30. We don't have those errors anymore. That means they're set, but those properties aren't readable. That's why we need getters. Let's get the first name, get first name, return this private first name. There's SpongeBob, his first name. Get last name. Return this private last name. There's his last name. Let's create a getter for a full name too. Let's console.log a full name, even though we have no property for that. That's undefined. We'll use a getter to mimic a full name property by just combining the first name and the last name properties. Get full name, return, I'm going to use some string concatenation, this private first name plus a space character, this private last name. And there's his full name, SpongeBob SquarePants. And the age. Get age, return this private age. And SpongeBob is 30. All right, everybody, those are getters and setters. Getters are special methods that make a property readable. Setters are special methods that make a property writable. By using a combination of both, we can validate and modify a value when reading or writing a property. And well, everybody, those are getters and setters in JavaScript. Hey, what's good, everybody? So in today's video, I'm going to give you a lesson in destructuring in JavaScript. Destructuring allows us to extract values from arrays and objects, then assign them to variables in a convenient way. We can use straight brackets to perform array destructuring, or curly braces to perform object destructuring. I'll give you 5 different examples. Example 1. Swap the value of 2 variables. We'll have let A equal 1, let B equal 2. To use array destructuring, we need a set of straight brackets. Add the variables A, comma, B. This will equal, we're creating a new array on the right-hand side. B, comma, A. On the left-hand side of our equals, we're using destructuring. On the right-hand side, we're creating an array. Let's see what's within variables A and B. Console.log, variable A, then variable B. So if these values are swapped, we should have 2, then 1, not 1 and 2. That's example 1. We can use destructuring to swap the value of two variables. Example 2. We can swap two elements in an array. Let's create an array of colors. Const colors equals an array. Pick some colors. I'll go with RGB, so that would be red, green, blue. Let's add black and white. Suppose I would like to swap the position of the first element and the last element. This first element has an index of 0. This particular last element has an index of 4. Again, we're going to use array destructuring. We need a set of straight brackets. We'll take our array, colors, at index of 0, comma, our array, at index of 4. We want to swap red with white. 0, 1, 2, 3, 4. That's the fourth index. Equals, we're creating a new array by using straight brackets, colors at index 4, comma, colors at index 0. Then let's print our array. Console.log, our array of colors. There we go. We have white, green, blue, black, red. That's how we can use destructuring to swap two elements in an array. Example 3. We can assign array elements to variables. We'll declare a bunch of variables. Const. We'll use destructuring. We're destructuring an array. We need a set of straight brackets. We'll create some variable names. First color. Second color. Third color. I will assign this equal to our array colors. Let's print these variables. Console.log, our first color, we have red. Second color, green. Third color, blue. You could combine array destructuring with rest parameters. We have two colors left. Let's assign that to a new array. We'll use rest parameters. I will name this array extra colors. Then we will console.log extra colors. And that should be a new array that has the remaining colors, black and white. That's how to assign array elements to variables using destructuring. Example 4, extract values from objects. We'll create two people objects. Const person1. Person1 will have a few properties. First name will be SpongeBob. Last name will be SquarePants. Age will be 30. And a job, meaning occupation. Not John, job. His job is that he is a fry cook. Alright, let's copy person1. Looks like that N should be capital in last name. Alright, let's copy person1, paste it, change person1 to person2. The first name of person2 will be Patrick. Last name, Star. Age will be 34. Person2 is not going to have a job property. He's unemployed. Using destructuring, I can extract values from these objects. We'll create a few variables. Const. We'll use object destructuring. We need a set of curly braces this time. We'll create these variables. First name, last name, age, and job. Now this equals, let's start with person1. Let's display these variables. Console.log, first name is SpongeBob. Last name, SquarePants. Age, 30. Job, fry cook. Let's do this with person2. Patrick Star, his age is 34. Person2 does not have a job property. Person1 does, though. Our job variable is undefined, as you can see here. You can set default values when using destructuring. If somebody doesn't have a job property, we'll set job to equal unemployed. Let's see if that works. Yep, Patrick Starr, age 34. His job is he's unemployed. That's how you can extract values from objects. Values extracted can even have default values. Alright, last example. We can destructure in function parameters. We can pass an object to a function and destructure it when it's passed in. Let's create a function. We will create a function to display a person. With the parameters, we'll use destructuring. We're destructuring an object. We need a set of curly braces. We'll receive an object, such as this. I'm going to invoke display person. We'll pass in person1 as an argument. When we receive person1 as an argument, we'll destructure that object right away. We will create a first name parameter, last name, age, and job. All we'll do is print a few lines using console.log. I'll use a template string. Let's say name, colon space. I'll add a placeholder, first name, and last name. Let's add a new line. Age, colon space, add a placeholder, age. Then lastly, job. Job, colon space, add a placeholder, job. We're passing in person1 and destructuring it. We should display name, SpongeBob SquarePants, age 30, job, fry cook. Let's pass in person2 as an argument. Name, Patrick Starr, age 34, job is undefined. Again, we can set a default value when destructuring. If an object doesn't have a job property, we will set that equal to be unemployed. Patrick Starr, age 34, job unemployed. Then if we pass in person1 again, his job should not be unemployed. He's a fry cook. There is a job property, so we do not use the default value. Alright everybody, so those are a few examples of destructuring. There's a lot you can do with destructuring. You use a set of straight brackets to perform array destructuring, or curly braces for object destructuring. They allow you to extract values from arrays and objects, then assign them to variables in a convenient way. And well, that is destructuring in JavaScript. So yeah, we're doing a thing today. Today I gotta explain nested objects in JavaScript. Nested objects are objects inside of other objects. They allow you to represent more complex data structures. A child object is enclosed by a parent object. By using nested objects, we have the capability of creating some very complex data structures. For example, a person object could contain an address object, as well as a contact info object, or a shopping cart object. Each item in your shopping cart is an individual object, such as a keyboard, a mouse, or a monitor. Each of these child objects would have their own properties and methods. For example, a price, a name, specifications on the item, a shipping method. Nested objects are just objects inside of other objects. Let me give you a basic example. We'll create a person object. Const person equals an object. We need a set of curly braces. A person might have a full name property. I will set that to be SpongeBob in this example. SpongeBob SquarePants. An age of 30. Is SpongeBob a student? Is student. He's in boating school, so let's say that's true. Objects can also contain arrays. We'll create an array of hobbies. To declare an array, you need a set of straight brackets. What sorts of hobbies does SpongeBob have? He knows karate. He does jellyfishing. I need one more. Let's say that he enjoys cooking. Now we're going to create a nested object. This person object will have an address object. So we need a set of curly braces. A few of the properties of the inner address object could be a street. SpongeBob has an address of 124 Conch Street. His city will be Bikini Bottom, and a country. We won't do a full address, but I think this is good enough for this example. So SpongeBob lives in the ocean. Let's say that his country is international waters. I'll just abbreviate international. Our person object has a nested address object inside of it. To access some of these properties of our person object, we would type the name of the object, use the property accessor, which is dot, then the name of the property, full name, SpongeBob SquarePants. Let's print his age. 30. Is SpongeBob a student? That is true. I'm going to display the array of hobbies. Person.hobbies. This will give you an array. But if you need individual elements, you have to list an index number. So hobbies at index 0 would be karate. 1 is jellyfishing. Index 2 is cooking. Let's console.log our person object dot the address object. This would return an entire object. If you need one of the properties within this object that's within the person object, you would have to follow the inner object with the property accessor again, that dot. Person.address.street, which would give you 124 Conch Street. The city, person.address.city, Bikini Bottom, person.address.country, international waters. So when accessing a property within a nested object, you have to use the property accessor twice, that dot. If you would like to loop through the properties of a nested object, you can write a for loop like this. For const property in person.address console.log, take our person object, access the nested object, address, then use the index of operator, the straight brackets, give me the current property, and there we are. All right, let's make something a little more complicated. We're going to create a class that utilizes nested objects. So we will begin with class address. Our class will have a constructor. For an address, we need these three things. Feel free to add more if you would like. A street, city, and country. Then we'll assign these properties. This.street equals street. This.city equals city. This.country equals country. Now we'll create a person class. Class person. Our person class will also have a constructor. We'll need a name, age, and an address. For the address, I'm going to use rest parameters. We can pass in different parts of an address and store it within an array. When we create a person object, we will assign this.name equals name. This.age equals age. Now for the address, we're going to construct an address object. This.address equals a new address. We're going to call the constructor of our address class and pass in our address. I'm going to utilize the spread operator to spread our address. We'll send our address object a street, city, and country. All right, let's construct some of these person objects. Const person1 equals a new person. This will call the constructor, but we have to pass in arguments to match the parameters. A name, we'll just do a first name to keep it short. An age, SpongeBob will be 30. We also need an address, a street, city, and country. 124 Conch Street. City will be Bikini Bottom. His country will be international waters. And just for readability, I'm going to put the address on a new line. Let's create person 2. Person 2 will be Patrick. age 37. Patrick will live on 128 Conch Street. He'll have the same city and the same country. Then let's make person 3. Person 3 will be Squidward. Age 45. Squidward will live on 126 Conch Street. Alright, let's see if this all worked. Console.log. Let's start with person 1. Person 1.name, which is SpongeBob. Age 30. Let's get his address. Address, and this returns an object, which is good. That's what we wanted. We have a nested object, an address object. For some of the properties within that address object, we have a street, city, and country. We use the property accessor again, of dot. Give me the street, 124 Conch Street, the city, Bikini Bottom, and the country, international waters. Alright, let's confirm this with person 3, just to be sure it all works. Person 3, give me the name, Squidward, age, 45, address gives me an object, we'll use the property accessor again, give me the street, 126 Conch Street, the city, Bikini Bottom, and the country, international waters. This will also all work for person 2, if it worked with person 1 and 3. Alright everybody, so those are nested objects. They're objects inside of other objects. They allow you to represent more complex data structures. A child object is enclosed by a parent object. In this example, our address is the child object of the person object. We're creating a new object within our person object. And well everybody, those are nested objects in JavaScript. Hey, what's up everybody? So in today's video, I'm going to show you how we can work with an array of objects in JavaScript. What we'll do is create an array of fruit objects. We'll create 5 fruit objects. To create an object, you need a set of curly braces. Each object will be comma separated. Just for my own readability, I'm going to place each object on a new line. Objects can have their own unique properties and methods. Our first fruit object will have a name of apple, a color of red, and calories, meaning calories per serving, of 95. This is our first object. Let's copy these properties, paste them for object 2, change name to be orange, color will also be orange, calories 45. Object 3, name will be banana, color yellow, calories 105. Object 4, coconut, color white, calories 159. Then our last object will be pineapple. Color yellow, calories 37. Alright, and here is our array of objects. There's a lot we can do with this. If you ever need a property within one of these objects of your array, you would take the array, in this case fruits, add an index number, dot the name of the property. For example, name. I need the name property of the first object, which would be apple. So let's test that. Console.log. What is the name property of our array fruits at index 0? That would be apple. 1 is orange, 2 is banana, 3 is coconut, 4 pineapple. Let's select a different property. Let's go with the calories. 95, 45, 105, 159, 37. That's how to access a property within an array of objects. To add a new object, you can use the push method. Let's take our array of fruits, use the push method. We will push a new object into our array. The name will be grapes, color purple, calories 62. Then let's console.log our array. console.log fruits. So we have 6. Apple, orange, banana, coconut, pineapple, and grapes, which I misspelt. Grapkes. You can use the pop method to remove an element. Fruits.pop. This should remove pineapple. Apple, orange, banana, coconut, no pineapple. Or splice. Splice will remove elements at certain indices. Fruits.splice. Let's select indices 1 through 2. All we're left with is apple, coconut, pineapple. You can use the for each method to loop through the elements of your array. Let's display each object's name. Fruits.forEach. We need a callback, a function expression, or an arrow function. Let's use an arrow function. For every fruit, do this. Console.log each fruit. This will return entire objects. For one of the properties, we'll select dot the property name. We have all the fruit names. Let's go with the colors and the calories. There we are. There's also the map method. The map method will run each element through a function and return a new array. Let's create an array of fruit names. Const fruit names equals take our array of fruits, use the built-in map method. We'll use an arrow function. For every fruit, arrow, return the fruit's name. Then we will console.log our array of fruit names. And here's our array of fruit names. Let's do this with colors. Fruit colors. Return every color property of each fruit. Then console.log our fruit colors. Red, orange, yellow, white, yellow. Let's do this with calories. Fruit calories. Return each calories property. Console.log our fruit calories array. So the map method will return a new array. Let's cover filter. Filter will return a new array after using each element and checking a condition. Let's return a new array where the color of each fruit is yellow. There's 2. Const yellow fruits equals take our array of fruits, use the filter method. We have one parameter, a fruit, arrow, then a condition. We'll return this fruit if the fruit's color property is strictly equal to yellow. Then console.log our array of yellow fruits. And there's 2, bananas and pineapples. Their colors are both yellow. Let's create a new array of any fruits that are low in calories, where the calories are below 100. Const low cal fruits. Take our array of fruits, use the built-in filter method. For every fruit, arrow, check the calories of each fruit. Is it less than 100? If it is, put it within this new array. And here we are. We have 3 fruits that are low in calories. Apple, orange, pineapple. The calories are 95, 45, 37. They're all less than 100. Let's find any high-calorie fruits. Change our array to be high-cal fruits, where the calories of each fruit is greater than or equal to 100. Console.log our array of high-cal fruits. There are 2. Bananas and coconuts. The calories are 105 and 159. Let's use the reduce method now. I'll admit this is going to be a little tricky, but I'll try my best to walk you through it. The reduce method will return a single value, in this case, an object, one of these objects. Let's return the object with the greatest amount of calories. We'll store that within a constant. Const max fruit equals take our array of fruits, use the reduce method. There's going to be 2 parameters. An accumulator, which keeps track of the greatest value during each iteration, and the next element. But I think we should rename these. let's rename our accumulator as max. It's going to be the current record holder of the object with the greatest amount of calories. Element will be fruit, meaning the next fruit. Here are the two parameters. Arrow, what are we going to check? Is our fruit, the next fruit in line, are the calories greater than our current record holder's calories? Max.calories. Just for readability, I'm going to put this on a new line. We're going to use the ternary operator. Is this true? Does the next fruit have more calories than our record holder? If it does, we'll return our fruit, meaning the next fruit. Colon, meaning otherwise, return the max again. Let's see if this works. Let's console.log our fruit with the maximum amount of calories, which is our coconut, with 159 calories. If you just need the calories, you would type .calories. That will just give you the calories. But in this case, we're returning an entire object. Let's find the fruit with the least amount of calories. Let's copy our code, paste it, and make a few changes. Min fruit, change max to be min. The condition will be, is the calories of the next fruit less than the calories of the minimum record holder? Then console.log our min fruit, which is our pineapple with 37 calories. Alright everybody, so those are a few ways in which you can work with an array of objects. There's a lot you can do with them. You can map, you can filter, you can reduce, you can splice, you can pop, you can push, all sorts of things. And well, that is an example of an array of objects in JavaScript. Yo, so what's up? Today I'm going to be talking about the sort method in JavaScript. The sort method is used to sort elements of an array in place. However, with the sort method, we sort elements as strings in lexicographic order, not alphabetical. If I could summarize what lexicographic means, it means alphabet plus numbers plus symbols as strings. Let me give you an example with just alphabetical characters. I have an array of fruits. To sort this array, I can take the array name fruits, use the built-in sort method, then console.log my array of fruits. Let me expand this. And here's my array, all sorted. When sorting, we treat any elements as strings. What if my array were numbers? I'll add the numbers 1 through 10 in a somewhat random order. Let's change our array to be numbers. Numbers.sort, console.log numbers. Here's the result. We have 1, then 10, then the rest seem to be in order. We're not sorting this array numerically, we're sorting this array lexicographically. We're treating each of these numbers as strings. That's why we have 1, then 10. 10 isn't at the end where we expect it would be. There's a couple extra steps we need to do involving sorting numbers. Inside of the sort method, we have to write a custom comparison function. This is normally a callback, but you can write a function expression, or even better yet, an arrow function. We'll write an arrow function in this case. Let me zoom in. With an arrow function, we first need parameters. We'll have parameters A and B. We'll examine two contiguous elements. 1 then 10, 10 then 2, 2 then 9, 9 and 3, so on and so forth. Then we need an arrow. Then we'll write A minus B. Our function A minus B will return either a negative, 0, or positive value, depending on what values we're examining. The sort method will sort those values into place depending on what the value returned is. Our array should be sorted. You can see that 10 is at the end, instead of right after 1. For reverse order, you could say B minus A. Now we're starting with 10 and ending with 1. You can even sort objects by a given property. Let's go over that example. We will create an array of people. Const people equals, this will be an array. We'll include 4 objects. all comma separated. The first will have a name property of SpongeBob, age 30, and a GPA. GPA 3.0. I'm going to zoom out. For the next object, just going to put that on a new line. Let's copy all of these properties, change name to be Patrick, age will be 37, GPA 1.5. Again, for the next object, we will have Squidward, age 51, GPA 2.5. Then lastly, we'll have Sandy. Name, Sandy. Let's make Sandy 27. GPA, of course, it's going to be a 4.0. I would like to sort this array of objects by each person's age. We'll take our array of objects that's stored within people, use the built-in sort method, use our arrow function, A, comma, B, arrow. We'll take parameter A, that's person 1, dot, access their age property, minus parameter B, access their age property. And that's all you got to do. Now let's console.log our people. There we are. We have Sandy, who's the youngest, then SpongeBob, Patrick, Squidward. For reverse order, you'll just change A to be B and B to be A. Squidward, Patrick, SpongeBob, Sandy. Or we can sort by a different property. Let's do GPA this time. A.GPA, B.GPA. We have Patrick with the lowest GPA, followed by Squidward, SpongeBob, Sandy. Then reverse order would be B.GPA minus A.GPA. Sandy, SpongeBob, Squidward, Patrick. Let's try sorting by the name property and see what happens. A.name minus B.name. We have SpongeBob, Patrick, Squidward, Sandy, but that doesn't seem to make sense. These aren't in alphabetical order. If you need to sort by a property that contains a string within an object, there's a different formula. We will take A.name, use the built-in local compare method, compare to B.name. This method will examine two strings for lexicographic order. Now these are all arranged lexicographically, starting with Patrick, then Sandy, SpongeBob, Squidward. For reverse lexicographic order, we would take B.name.localCompare, then examine A.name. I've just now realized that there's a lot of SpongeBob characters whose first name starts with an S. Like we have 3 right here. Squidward, SpongeBob, Sandy, Patrick. Alright everybody, so that is the sort method. It's used to sort elements of an array in place. It sorts elements as strings in lexicographic order, not alphabetical. And well everybody, that is the sort method in JavaScript. Hey everybody, in today's video I'm going to show you how we can shuffle the elements of an array using JavaScript. This is an optional video. You might find this topic helpful if you're interested in making a game using JavaScript, or any sort of application where you need some randomness. In this example, we'll create a deck of cards. Our deck of cards will be an array. We have an A for ace, the numbers 2 through 10. Let me finish typing those in. J for jack, Q for queen, K for king. I'm not going to include any suits for these cards, such as ace of hearts, ace of clubs. That might be overkill for this example. One method you might see floating around online to shuffle the elements of an array is to use the sort method, then pass in an arrow function where you take math.random minus 0.5. I would not recommend using this method just because the results of this method aren't perfectly uniform. Let me console.log cards. This array appears shuffled, but it's not that uniform. But not only that, the larger the array becomes, this method becomes increasingly more inefficient. I would not recommend using the sort method to shuffle an array. Instead, I would recommend using the Fisher-Yates algorithm. We'll create a dedicated function for this. So we will define a function to shuffle. There will be one parameter, an array. Then to invoke this function, we'll type the function name, pass in our array of cards. So what do we want to do exactly? We're first going to loop through the elements of this array. We'll start at the end and work our way towards the beginning. We'll use a for loop to decrement. So within our shuffle function, we'll create a for loop. We will declare index of I, let I equal our array dot length. Then -1. That's the first statement. Our array has 13 elements, but the last index is 12 because arrays start with 0. If the array's length is 13, we need to subtract 1 to get 12, which would give us the ending index of 12. We'll continue this loop as long as I is greater than 0. Then I minus to decrement. Now we have to generate a random number between the end and the beginning, somewhere within this range. We'll create const random. Random will store a random number. Take math.random method times I, our index, plus 1. We'll need to round this number. We're now going to enclose this equation with math.floor to round down. Math.floor, and enclose this equation. All right, during the first iteration of this loop, we should generate a random number between the end and the beginning. We'll swap our king with a random element within this array. So to swap two elements of this array, we can use destructuring. In this context, to use destructuring, we'll take our original position, array at index of I. During our first iteration, that will be the king. We'll swap our king with our array at a random index, the one that will be randomly generated, equals our array at index of random, comma, array at index of I. Then to finish using destructuring, we need to enclose both sides of this equation with an array. There, and that will swap two elements of your array. Now, if I run this program, this will shuffle the elements of my array. I would recommend using a dedicated shuffle function, because in a game, it's likely you're going to shuffle something more than once throughout that game. Like I said, this isn't a necessary topic to continue on with the series, but if you're ever interested in making a game using JavaScript or need some element of randomness, well then this function would work great. And that is how to shuffle the elements of an array using JavaScript. What's up, everybody? So in today's video, I'm going to explain date objects in JavaScript. Date objects are objects that contain values that represent dates and times. These date objects can be changed and formatted to suit our needs. Here's an example. We will create a date object that contains the current date and time. To do so, let's create a constant named date. Date will be an object. We will call the date constructor with the new keyword, date. Then pass in no arguments for the current date and time. So I'm going to console.log my date object, which gives me my current date and time. As of right now, I'm filming this video on a Thursday, November 9th, the year 2023, at about 7 in the morning. So depending on when you're watching this video, the date and time is going to be different. If you would like to create your own custom date and time object, you'll have to pass in some arguments. You can follow this order for the date constructor. The first argument corresponds to a year, then month, day, hour, minute, second, and milliseconds even. So for the year, let's say 2024, the month, 0 corresponds to January, 1 is February, then that means a month of 11 is December. Let's say January, so that will be 0. For the day, 1 for the first. For the hour, 2 in the morning. This is in military time, by the way. For the minute, 3 minutes after the hour. For the seconds, 4 seconds after the minute. We can even add milliseconds if we would like. So for the milliseconds, let's say 5. And here's my new date object. Monday, January 1st, 2024, about 2 in the morning. Passing in a string representation of time to the date constructor is also valid. Let's say the year is 2024, January 2nd. For the time, you're going to type T for time, 12 noon. Then add Z for UTC time. And there's my new date again. Tuesday, January 2nd, 2024, 6 in the morning. Another format you can use is within the date constructor, pass in a given amount of time in milliseconds since epoch. If I could describe epoch, I would describe it as when the date your computer thinks time began. If you were to pass in 0 to the date constructor, you'll be given a date and time around December 31st, 1969. So within the date constructor, you can pass in a given amount of milliseconds since this date. So if I was to pass in 1.7 billion milliseconds, what I'm telling the date constructor is, give me the date and time that's 1.7 billion milliseconds since that epoch date. When I pass in 1.7 billion milliseconds, the date that I'm given is Tuesday, November 14th, 2023, about 4 p.m. Passing in milliseconds would be good for some sort of timer. Now let's use the current date and time. I will pass in no arguments. You can extract individual values from a date object. I would like the year. Const year equals take our date object. I will use the get full year method to get the year. Then I will console.log the year, and this will be a number, 2023. Let's get the month. Const month equals our date object. Use the built-in get month method. Then I will console.log the month. Currently for me, it's November, not October. So remember, January is 0. December is 11. Let's get the day. Const day equals date, get date, not day. If you get the day, that will give you the day of the week, like Sunday, Monday, Tuesday, that sort of thing. Let's console.log the day. So for me, it's the 9th. Let's get the hour. Const hour equals date, get hours, plural. Console.log the hour. For me, it's 7 in the morning. Let's get minutes. Const minutes equals get minutes. Console.log the minutes. It is 7:45 in the morning. Get seconds. Get seconds. Console.log the seconds. So 7:45, 21 seconds after the minute. Now, if you need the day of the week, here's what you can do. Const day of week equals date, get day. That will give you the day of the week. Console.log day of week. For me, that is for Sunday is 0, Monday is 1. So that means it is Thursday. Now with the date object, you can even set the date with the method. Let's console.log the date. I'm going to set the year. Date set full year. I will set the year to be 2024. Yep, Saturday, November 9th, 2024. Let's set the month. Set month. I will set the month to be January, so I will pass in 0. Tuesday, January 9th. Let's set the day. That would be with set date, not day. I will set it to be the 1st, January 1st. The hours with set hours. Let's go with 2 for 2 in the morning. Set minutes. 3 minutes past the hour. Set seconds. 4 seconds past the minute. You can even compare dates as well. Let's create 2 date objects. Const date1 equals a new date. I'll pass in a string representation of a date. We won't include the time though. For the year, let's say 2023. December, that would be 12/31. New Year's Eve, basically. And for date 2, let's say date 2 is New Year's Day, 2024, January 1st. Using an if statement, let's compare to see if date 2 is greater than date 1. If it is, then let's console.log Happy New Year. So date 2 is greater than date 1. We'll print Happy New Year. Let's change date 2 to be 2023, December 30th. Well, nothing happens then, but that's to be expected. Alright everybody, so those are date objects. They're objects that contain values that represent dates and times. These date objects can be changed and formatted to suit our needs. And well everybody, those are date objects in JavaScript. Hey, what's going on everybody? So in today's video I gotta explain closures in JavaScript. A closure is a function defined inside of another function. The inner function has access to the variables and scope of the outer function. By using closures, they allow for private variables and state maintenance. JS libraries and frameworks such as React, Vue, and Angular use closures all of the time. You'll see closures fairly often with function-based components. You have functions inside of other functions. Let me give you a very basic example. We'll have an outer function named outer. Within the outer function, we'll have a function named inner. The inner function has access to everything within the outer function, this scope. If I was to create a variable, let message equal the word hello, within my inner function, I can use this message variable. Console.log my message. Now if I invoke the outer function, nothing appears to happen. When we call the outer function, we're now within the scope. But then what? There's one of a few things we could do. If I would like to call the inner function from within the outer function, I would need to call it somewhere here. Let's call the inner function at the end. There we go, we have displayed the word hello. Everything within the outer function is part of a closure. We have a function defined inside of a function. This inner function has access to everything within that scope, including this message variable. One benefit of using closures is that any variables are considered private. Outside of the outer function, I will attempt to update our message. Message equals goodbye. Now this doesn't work, as you can see. This message variable is in a different scope. It's kind of like it's in another dimension. What we've done here is we have created a different message variable in a different scope. Outside of the outer scope, I have no way of accessing the message variable. So that's one of the benefits of closures. You can encapsulate variables and make them private. Let me give you another example. A closure can maintain the state of a variable. We'll create a counter program. So I'm going to create a function to increment. Within the increment function, I will set a count variable equal to 0. I will increment our count by 1, then console.log. I'll use a template string, count increased to, I'll add a placeholder, we'll display our count variable. Now, anytime I attempt to call the increment function, it'll increase our count by 1. But if I was to execute this function again, well, we're redeclaring this variable of count. We're resetting it every time we call this function. I can't get the count to go past 1, because we keep on resetting it. But by using a closure, we can have state maintenance. We can maintain the state of this variable, and remember where this variable was previously. I mean, I could take this variable and declare it outside of the function, but then we don't have any security for that variable. I will set the count equal to 1,000,000. We're maintaining the state of that variable, but it's not private. Anybody and anything can access and change that variable. A closure maintains the state of a variable and makes it private. What we'll do is enclose all of this code within another function. We'll create a function to create a counter. How do we access the scope within the createCounter function? Here's another possibility. We will return an object. We will need a set of curly braces. Our object will have a property of increment, and its associated value will be a reference to increment. There is a shorthand version of this. You can just use the function name as a property. We're returning an object with a method of increment. So now I'm going to create an object named counter. Counter equals invoke the createCounter function. This will return an object that has an increment method. So I'm going to take our counter object, use the increment method. Count increased to 1. Not only do we have an increment method, we have a count variable as well. You could say that what we've done with this outer function, it's very similar to creating a class. We can use classes to instantiate objects. In this case, we used a function to return an object. So if I was to take my counter and increment it again, our closure should maintain the state of that variable count. Count increased to 2. It's not resetting every time we call the method. Count increased to 3. Let's attempt to access our count variable. Counter.count equals 0. Then I will console.log our count. Reference error, count is not defined. Let's attempt to display our count variable. Console.log, take our counter object, access the count variable. It is undefined. We don't know what it is. It's hidden. Your closure can have more than one function. So what we'll do is create a getCount function. We'll use the getCount function to return our count if we need access to it. Function getCount. We will return our count variable. Within the return statement, we're returning an object. We will add another property of a reference to the getCount function. So now within our counter, we have a method to get the count variable. Let's console.log. I'll use a template string. The current count is, I'll add a placeholder, take our counter object, use the getCount method. The current count is 3. If I was to increment our counter again, well, that increased to 4. All right, last example. We're going to create a closure for a game where we keep track of points. We have a score. Let score equals 0. We'll define the functions. Function increase score. We'll have one parameter, points. In order to score some points, we have to pass in some points as an argument. Take our score plus equals our points. Then let's console.log. I'll use a template string plus add a placeholder, our points. Then I'll add PTS, meaning points. It's shortened. Let's create a function for decrease score. Change increase to decrease. Score minus equals points minus points. And then let's get our score. Function get score. Return the score. If I need to increase the score, I will invoke the increase score function. But I have to pass in points. We scored 5 points. Let's do this again. We scored 6 points. Let's decrease the score. I will subtract 3 points. Minus 3 points. Let's get the current score. Console.log. I'll use a template string. The final score is, add a placeholder, get score. The final score is 8. I'm going to add points after that. 8 points. All right, problem with this is that we can take our score and set it to anything. You scored like a kajillion points. So for some security, let's enclose all of this code within a closure. I'll create an outer function. Function create game. This will return an object. Let's cut all of this code, paste it within the outer function of create game. And then at the end, we will return an object that has references to these functions. Return an object. We need curly braces for that. A reference to increase score, decrease score, and get score. So now, I will use the create game function to return an object. Const game. Game will be our object. We will invoke the create game function and return an object. So now if I want to increase the score, decrease it, or get the score, I have to use the methods of this object. Game.increaseScore, game.decreaseScore, and game.getScore. We have 5 points, 6 points, minus 3 points, and then we have the final score of 8 points. Well, everybody, those are closures. Think of them as a function defined inside of another function. The inner function has access to the variables and scope of the outer function. These are used frequently with JS libraries and frameworks such as React, Vue, and Angular, especially when you work with function-based components. And well, everybody, those are closures in JavaScript. Hey, what's going on, people? So in today's video, I'm going to explain the setTimeout function in JavaScript. The setTimeout function allows you to schedule the execution of a function after an amount of time, in milliseconds. The times are approximate. They vary based on the workload of your JavaScript runtime environment. I wouldn't recommend using setTimeout for anything precise like a stopwatch. It's an approximation. To use the setTimeout function, you pass in a callback to a function and a delay in milliseconds. Here's an example. I will create a function to say hello. All we're going to do is window.alert the word hello. I will use the setTimeout function, pass in a callback. We'll pass in a callback to say hello, then execute it after 3000 milliseconds, so 3 seconds. Let's see if this works. 1, 2, 3, hello. An anonymous function works too. So instead of a callback, we'll use an anonymous function. Function, parentheses, curly braces, window.alert the word hello. 1, 1000, 2, 1000, 3, 1000, hello. Or even an arrow function. We have parameters, arrow. What are we going to do? Window.alert the word hello. 1, 1000, 2, 1000, 3, 1000, hello. You can use the clear timeout function to cancel a timeout before it triggers, but we have to pass in a timeout ID. So what we'll do with this setTimeout function is assign it to an ID stored within a variable or constant. Const timeout ID equals our setTimeout function that'll display the word hello. I can clear this timeout with the clear timeout function, but I have to pass in that ID as an argument. Immediately after calling the setTimeout function, we will cancel it. Let's try it. 1, 1000, 2, 1000, 3, 1000. Yeah, nothing's happening. We canceled it. Alright, what we'll do this time is create a button using HTML. When we click on the button, we'll set a timeout to display the word hello. So let's clear all of this, go to our HTML file, we'll create a button. The button will have text of start. And I'm going to zoom in. I will set the onClick attribute to equal a function. We will start a timer, then add a set of parentheses. When we click on the button, do this function. So within our JavaScript file, we will create a start timer function. Function start timer. We will set timeout. I'll use an arrow function. Let's window dot alert the word. We will display the word hello after 3000 milliseconds. All right, so nothing's gonna happen until I click the button. I'm gonna click it now. 1,000, 2, 1,000, 3, 1,000. Hello. Let's create a second button to clear the timeout if we need to stop it. Let's copy our first button, paste it, change the text of the button to be clear. We will clear the timeout, but we'll need another function. Clear timer. So there's our second button. We'll need a timeout ID. So outside of this function, I will declare a variable of letTimeout ID. When we start our timer, we will assign the setTimeout function an ID of timeout ID. Then we can stop it using this ID. We will create a function to clear the timer. We're going to use the clear timeout function. Clear timeout. We need to pass out a timeout ID as an argument, which we will do. And then just to be sure that everything works within both these functions, let's console.log something. Let's say the word started within our start timer. And within our clear timer, let's display the word cleared, just so we know that these functions were called. So I'm going to save everything. I'm going to start the timer, but not clear it. Let's start now. 1,000, 2, 1,000, 3, 1,000. Hello. Let's go to our console. And it says that we started. Well, starter. I clearly can't spell today. Started. We're going to start, then cancel. Start, 1,000, 2, 1,000, clear. And nothing happened. Let's go to our console, inspect, console. We started set timeout, and then we cleared it. All right, everybody, that is the set timeout function. It's a function in JavaScript that allows you to schedule the execution of a function after an amount of time in milliseconds. Execution time may vary based on the workload of the JavaScript runtime environment. And well, everybody, that is the set timeout function in JavaScript. Hey, what's going on, people? So in today's video, we're going to create a digital clock using JavaScript, HTML, and CSS. So let's get started. The HTML for this project is going to be very minimal. I will create a div element. The ID of the div element will be clock-container. Within this div element, we'll have a nested div element with an ID of clock. We have a clock within a clock container. As a placeholder, temporarily, the text on the clock will be 00:00:00:00. 00000000. And I'm just going to zoom in temporarily. And that is all the HTML that we need. Let's head to our CSS style sheet. Let's begin with the body. I will set all margin to be 0 originally. Let's select our clock container. ID, clock, container. I'll use Flexbox for the clock container. Display, flex. I will justify content in the center. Justify, content, center. If you would also like to vertically align, you'll need to add the following 2 lines of code. I will align, items, center. This CSS property will vertically align any elements, but the clock container itself is kind of small. For example, I'll add a border of 2 pixels solid. The elements within the clock container are aligned both horizontally and vertically, but the container itself is kind of small. To vertically align this element within the window itself, we'll have to increase the height of the clock container. I will add height of 100 VH for the viewport height. And we can remove the border. Yep, the clock is now within the middle of the container, both horizontally and vertically. But if you prefer it to be at the top, you can eliminate these last two lines. It's up to you. Let's style the clock itself. We are selecting the ID of clock. I will change the font family to be monospace. This is the normal size when I'm zoomed into 100%. I will set the font size to be 6.5 REM. Then set the font weight to be bold. And text, align, center. If you would like a background image for the body of your document, I just so happen to have one right here. It's a picture of Central Park in New York. This is optional, but if you would like to include a background image of this project, within your CSS style sheet, you'll add the following CSS properties. I will set the background image property to be a URL. So what is the name of that image? I'm going to copy the name of it and paste it within this URL function. I'll set the background position to be the center. Right now we're seeing the top left of the image instead of the center. Background position will be center. If you're using a small image, your image might be repeating itself to take up all the available space. To prevent that, you can set the background repeat property to be no repeat. Mine already wasn't repeating though, but yours might be. Then we'll set the background size to cover. By adding this property, this image will cover the entire window and maintain its aspect ratio. If you do have additional content besides this clock, you can keep the background in place when you scroll down by adding this property. Background attachment to be fixed. This property isn't going to be apparent because we don't have a scroll bar, but if you did have a scroll bar, the background will stay in place at least. Let's head back to our clock element. I will change the color, the font color, to be white. If you would like a background blur effect, you'll add this property. We'll set the backdrop filter property to be a blur function. The greater the number, the more blur effect you're going to have. So this is 5 pixels. If I were to increase this to 50, well, there's a lot of blur then. I'll set my blur to be 5. I would just like a little bit, as if we're looking through glass. I'll increase the width to be 100%, to take up 100% of the width of the web browser. Width 100%. To give this glass look a foggy appearance, we can add a background color that's slightly gray. Background-color. Let's select gray, but I like using HSL values. So for the lightness, I'll set it to be 100%, but I'm going to lower the alpha down to like 10%. Now the background has a foggy glass appearance. If you were to increase the amount of alpha, that'll increase the lightness. I'll keep mine as 10%, 0.1 for the alpha. Alright, now we just need to get this clock to run. So let's save everything, go to our JavaScript file. We will create a function to update our clock. Immediately when we begin this program, we will update our clock once immediately. Now we need to get the current time. Let's declare a constant of now. What is the time right now? This will be a new date object. To get the hour, we will say const hours equals, use the built-in get hours method. Then let's do this with minutes. Const minutes equals now dot get minutes method. and seconds. Const seconds equals now dot get seconds. I'm going to change the text content of the clock to be a time string. It will be a template string. How do we want to arrange our numbers? Const time string equals a template string. First, we'll add a placeholder for our hours, colon, minutes, colon, seconds. Then we will select the ID of clock. Document.get element by ID. The ID that we're getting is our clock. Change the text content to equal our time string. When we save, the time on the clock should update. Currently for me, it's 8 o'clock. For each of these placeholders for hours, minutes, and seconds, I would like each to take up 2 digits. We'll add some zeros for padding. For example, this time will be 080016. There's a built-in string method for that. So with hours, minutes, and seconds, we will convert these to strings. We'll use method chaining, then add toString. Do this for hours, minutes, and seconds. With strings, there's a pad start method. For the first 2 characters, pad them with a 0. Let's copy this method and paste it for minutes and seconds. Now, when I save and update the time, we have 0 padding. 08, 01, 54 in this case. To get this clock to update every second, we'll follow update clock with the set interval function. Set interval works like set timeout, except it will call a function repeatedly, not just once. But we need a callback. The callback will be update clock. Call this function after every 1000 milliseconds. And now our clock should run. Currently, this clock is in military time, although I'm recording this at 8 in the morning. If you would like this clock to be a 12-hour clock, then add AM or PM, here's the following changes we're going to make. We'll declare hours with let instead of const so we can change it and reassign it. We'll create a new constant of meridium for AM or PM. This will equal hours. Is hours greater than or equal to 12? We'll use the ternary operator to check this. If hours is greater than or equal to 12, meridium will be PM. Otherwise, it will be AM. Then, after our meridium, we'll reassign hours. Hours equals hours. Modulus. Modulus gives you the remainder of any division. Hours modulus 12. If this is 0, we'll use the OR logical operator. Or 12. After seconds, we'll add a placeholder for our meridium. Currently, we lost our padding for the hours, so we're going to cut this part of our code to convert hours to a string and pad it. We'll take hours equals hours to reassign it, follow hours with converting it to a string using the toString method, and pad it before displaying it. All right, and that has appeared to work. All right, everybody, so that is a digital clock program you can make using HTML, CSS, and JavaScript. Hey, what's going on, everybody? In today's video, I'm going to show you how we can create a stopwatch program using JavaScript, HTML, and CSS. So sit back, relax, and enjoy the show. All right, let's get started, everybody. We will create an H1 heading with text of stopwatch, and I will give this H1 element a unique ID of my H1. Then we'll create a container for our stopwatch. This will be a div element. This div element will have an ID of container to contain everything. Our container is going to have 2 sections, 2 div elements. The first div element is going to be for our display. ID display. I'll give this div element some initial text as a placeholder. We'll have zeros for hours, minutes, seconds, and milliseconds. Then our next div element will have an ID of controls for all the control buttons. Within this div element of controls, we'll create 3 buttons. The first button will be Start. The ID of this button will be Start Button, BTN short for button. Then I will set the onClick event handler equal to a JavaScript function. We will eventually create a start function. We still need to define it. Let's copy this button, paste it twice. The second button will be for stop. The ID will be Stop Button. The onClick attribute will be for a stop function. The text on the button will be stop. And then we have a reset button. The ID is Reset Button. The onClick attribute will be for a reset function. The text on the button will be reset. All right, and that is all the HTML that we need. Let's go to our CSS style sheet. I will first select the body of our document. We'll use Flexbox to display everything because I like Flexbox. Display flex. The flex direction will be a column. Then I will align items center. I'll set the background color of this application. Background-color. Pick a color. Again, I like using HSL values. I'll set the lightness to 90%. Our container is going to be a lighter color. We will select the ID of my H1. That's going to be the heading. I will set the font size to be 4 REM. The font family, I will pick Arial with a backup of sans serif. For the font color, I will set the color property to be pick a color. I'll pick black, but set the lightness to 25%. All right, now we are going to select the container that contains everything besides the heading. This area. We will select the ID of container. I will use Flexbox within the container. Display flex. The flex direction will be a column. And align item center. Let's add a border around the container. 5 pixels solid. And I will round the corners. Border, radius. Let's do 50 pixels. And I'll add a little bit of padding. Padding, 30 pixels. And I will set the background color to be white. Background color white. We'll work on the time display next. Select the ID of display. I will set the font size to be 5 REM. For the font family, I'm going to set it to be monospace. And the font weight, I will set to be bold. I'll change the color. I'll set the lightness to 30%. I'll give a text shadow to the display, so it looks like it's somewhat 3D, like it's popping out. So text, shadow, 2 pixels and 2 pixels for the vertical and horizontal offset, and a blur of 2 pixels. Now for the color, I'm going to lower the alpha to 75% or so. That's not bad. Then I'll add a little bit of margin to the bottom. Margin, bottom, 25 pixels. Now we have to style the buttons. We will select the ID of controls, but I would like the button elements within the controls. After selecting the ID of controls, select any buttons within that element. We'll increase the font size of the buttons. Font size 1.5 REM. I will set the font weight of the buttons to be bold. I'll add a little bit of padding, 10 pixels by 20 pixels. I'll add some margin around the buttons, 5 pixels. I'll set a minimum width of the buttons to be 125 pixels. Let me scroll down. I'll remove the border, border none. Set the border radius of the buttons to be 10 pixels. Change our cursor to be a pointer when we hover over the buttons. Let's see if that works. Yes, it does. Then set the font color of the buttons to be white. Now let's color the start button. We will select the ID of start button. Set the background color. Pick a color. I'll start with something green. Pick whichever color you would like. I'll pick this shade of green. Here are the values. When we hover over the start button, we will access the hover pseudoclass of our start button. I'll decrease the lightness by 10%. Let's copy the markup that we have for the start button, paste it twice. We'll add color to the stop button and the reset button. I'll set the stop button to be red. Here are the HSL values that I picked. When I hover over this button, I'll set the lightness to be 10% darker. For the reset button, I'll set that to be blue. When we hover our cursor over the reset button, I will set the lightness to be 10% darker. Not bad. For all of the buttons, I'm going to add a transition effect. Transition. Select the background color. We will create an ease transition after 0.5 seconds. We will ease. So when you hover your cursor over the buttons, there's going to be a slow transition when we hover. Okay, and that is all the CSS that we need. We will now go to the JavaScript file to add some functionality. Let's declare all the variables we'll need. We'll get the ID of the display and store a reference to it. Const display equals document.getElementById. The ID that I'm selecting is display. This ID. We will create a timer. Let timer equals null. Timer is going to hold the ID of set interval, so we can keep track of it and stop it if we need to. Then we need a start time. Let start time equal 0. Let elapsed time equal 0. Let is running. This will be a Boolean, which I will set to be false. If the stopwatch is currently running, we will flip this to be true, and flip it to be false to stop it. What are the functions that we need? We have a start, stop, and reset function. Function start, function stop, function reset. We'll add one more function of update to update the display. Function update. We'll begin with the start method. We'll enclose everything within our function within an if statement. We need to check to see if our stopwatch isn't running. If our stopwatch isn't currently running, if not running, then start the stopwatch. We need to set the start time. The start time equals, we will get the current date, date.now, minus the elapsed time, which will be 0 initially. So just to demonstrate what the start time is, I'm going to console.log my start time. So the start time is going to be in milliseconds since epoch. Epoch, basically speaking, is when your computer thinks time began. We will set our timer equal to the set interval function. We will call the update function every 10 milliseconds. So if I was to display my timer, console.log timer. This is what it is. Our timer stores a unique ID to work with this function if we ever need to stop it. We'll take the Boolean variable of isRunning, set it to be true, because our stopwatch is now running. Now we need to go to the update function to actually get it working. We need to get the current time. Const current time equals access our date. Use the now method. What is the date right now? We will calculate the elapsed time equals the current time minus our start time. Whatever that was when we initially pressed the start button. So the current time minus our original start time gives us the elapsed time. And this is going to be in milliseconds. We need to convert the elapsed time into a readable format using hours, minutes, seconds, and milliseconds. We'll begin with hours. Let hours equals take our elapsed time divided by, to convert milliseconds to hours, we can follow this formula. Elapsed time divided by 1000 milliseconds times 60 seconds times 60 minutes. We don't want any decimal portions with our hours. We will enclose all of this with the floor method of math. Now we're going to do something similar with minutes. Let minutes equals take our elapsed time. We need to convert milliseconds to minutes divided by 1000 milliseconds in a second times 60 seconds in a minute, then modulus 60. Modulus gives you the remainder of any division. We don't want our minutes display to hit 60 or go above 60. Once we hit 60, it'll reset back to 0. Enclose this formula with math.floor to round it. Math.floor. Okay, then we have to take care of seconds. Let seconds equals take our elapsed time divided by 1000 to convert milliseconds to seconds. Modulus 60. Enclose all of this with math.floor to round it. Now for milliseconds, let milliseconds equals take the elapsed time, which is already in milliseconds, modulus 1000. Milliseconds is normally 4 digits. We're going to divide it by 10. We only want the first 2 digits. Divided by 10. Enclose all of this with math.floor. Math.floor. Then let's change the display. We'll access our display. Access the text content of the display. Set it equal to a template string. If you would like to display the hours, it's optional. We will add a placeholder for hours, colon, placeholder, minutes, colon, placeholder, seconds. If you would like to display the milliseconds, we can add a placeholder for that, colon, placeholder, milliseconds. Let's see what we have so far. I'm going to hit the start button, and here's what we got. So the stopwatch is running, but we should add some zeros for padding. So I'm going to refresh to stop it. We'll convert hours, minutes, seconds, and milliseconds into a string, then add some padding of zeros to it, if the number is only 1 digit, not 2. We will convert hours, minutes, seconds, and milliseconds into a string before displaying it. So let's take hours equals hours. I will typecast it as a string. Follow this with the pad start method. For the first 2 digits, add a 0. Let's do this for minutes, seconds, and milliseconds. Minutes, seconds, and milliseconds. We should have some zeros for padding to make each display 2 digits. And that does appear to work. Nice. Now we just need to get the stopwatch to actually stop. Right now, there's no functionality. Going to our stop function, we need to check to see if our program is running. Is this variable is running? True. If is running, if that's true, then stop the stopwatch. We will use the clear interval function. We need to pass in that unique ID for the timer. This will stop the stopwatch from running. Then we will calculate the elapsed time. Elapsed time equals the date right now, date.now method, minus the original start time. Then set is running equal to false, because the stopwatch is stopped. It's not running anymore. Now we can start the stopwatch, and we can stop it. We can start it, and we can stop it. The last thing we need to do is reset the stopwatch. We can really just copy everything that we have when we initially assign these variables. We need to clear the timer, clear interval, pass in our variable timer that contains the ID of the set interval function. The start time will be 0. The elapsed time will be 0. Is running will be false. Change the text content equal to all zeros. This is for the hours, minutes, seconds, and milliseconds. All right, let's see if everything works just fine. We can start. We can stop. We can start. We can stop. We can reset. We can start. And we can stop. All right, everybody, so that is how you can create a stopwatch program using JavaScript, HTML, and CSS. Hey, what's going on, everybody? So today I'm going to explain ES6 modules in JavaScript. A module is an external file that contains reusable code that can be imported into other JavaScript files. Let's say you write a really difficult program. Well, any part of that program you can import into a different application if you don't feel like rewriting it. Modules can contain variables, classes, functions, and more. ES6 modules were introduced as part of the ECMAScript 2015 update. Using modules, we can create some reusable code that can be used in different programs, different JavaScript files. So what we'll do in this example, we will create a new file. I'll create a module for some math utility functions. This file will be math.util.js. It's a separate JavaScript file. From our index file, we will import this module, math.util.js. But in order to do so, within our HTML file, we have to set the type attribute equal to module. We'll now treat our index file as a module. We can import and export other modules freely, but we have to be sure to include this attribute and set it equal to module. So within our math.util module, we can write some reusable code for other programs. So let's define what pi is. Pi equals 3.14159. We'll create a function to get circumference. You have to pass in a radius, though. That's going to be the parameter. Function get circumference. We need a radius. We will return 2 times pi times radius. Then we'll create a function to get area. Get area. We still need a radius. We will return pi times radius times radius. Then get volume to get the volume of a sphere. Function get volume. Again, we need a radius. We will return 4 times pi times radius times radius. I can reuse these variables and functions for any JavaScript program that I have. I can import them. In order to do so, though, we need to be sure that we prefix each variable, function, or class, or anything else, with the export keyword, so that we can import it elsewhere. So let's be sure we do that. All right, be sure to save everything. We can close out of this module. Then from our index.css file, I will import. Then we're going to use object destructuring. We need a set of curly braces from the location of that module. So these files are right next to each other. Relatively speaking, they're right next to each other. I would need // the name of that file, math, util, and this is a JavaScript file. Now, anything I would like to import, I'll place within the set of curly braces. We're going to be using object destructuring. From this JavaScript module, I would like pi, comma, separate each entity. Then I would like get circumference, get area, get volume. I can now use these variables and functions as if they were already part of my JavaScript file. For example, I'm going to console.log pi, and pi does have a value because we imported it. Let's get the circumference, but we do need to pass in a radius. This is a function that we have imported from that math_utils module. I will store the result within a variable. Const circumference equals, we'll invoke the getCircumference function from that module. I'll pass in 10. Then we're going to display the circumference. I'll use console.log. I'll use a template string, include a placeholder, display the circumference, plus a unit of measurement, like centimeters. 62.8318 centimeters. This isn't necessary, but I'm going to round this number to 2 decimal places using the toFixed method of numbers. Let's round to 2 decimal places. Let's create an area variable. Const area equals get area. I'll pass in 10 for the radius. Let's copy this line and paste it because I'm lazy. Let's display our area variable with centimeters cubed. 314.16 centimeters cubed. Then we'll create a volume variable. Const volume equals get volume. I will pass in 10. And then we will display the volume. Volume centimeters cubed. And our volume, if we pass in a radius of 10, would be 1,256.64 centimeters cubed. All right, everybody, so those are modules. They're external files that contain reusable code that can be imported into other JavaScript files. You can write variables, classes, functions, and more that can be reused in other programs. You just have to be sure to import them. And well, everybody, those are ES6 modules in JavaScript. Yo, what's going on, people? So in today's video, I gotta explain what asynchronous code is in JavaScript. Synchronous is code that executes line by line consecutively in a sequential manner. Synchronous code waits for an operation to complete. For example, if I were to use console.log, let's pretend we're performing some task. It doesn't matter what the task is. We will pretend that task 1 is complete, then we'll move on to task 2, then task 3. All this code is synchronous. We're executing this code line by line. We can't move on to task 2 until we complete task 1. There's an order of events that we need to follow. It's code that waits for an operation to complete. Now, on the other hand, asynchronous code allows multiple operations to be performed concurrently without waiting. Asynchronous code doesn't block the execution flow and allows the program to continue. Imagine that asynchronous code is kind of like a time traveler. A time traveler can move out of the flow of time, but the rest of the world continues. Time resumes normally. Asynchronous code doesn't block the execution flow. Time moves on, with or without it. Asynchronous code is typically found with input-output operations, network requests, and fetching data, anything that could take an indeterminate amount of time. So for example, I will use the set timeout function. After 3 seconds, I will execute a function. Let's console.log, let's say task 1. We'll change these 3 lines to be task 2, task 3, task 4. I will finish task 1 after 3000 milliseconds. Now check this out. We've already completed task 2, 3, and 4, but task 1 finished last. That's because setTimeout is one of many asynchronous functions. The rest of the program isn't going to wait around for it to complete. It runs concurrently with the rest of my code. That's why task 1 was completed at the end, and not at the beginning. There's different ways to handle asynchronous code. We're already familiar with callbacks, but there's also promises, as well as async and await. We still need to discuss these topics in the future, but we're already familiar with callbacks. If it's crucial that task 2 through 4 finishes after task 1, we can use a callback. We don't necessarily know how long this asynchronous function is going to take. What we could do in this example is create a function. Function func1 meaning function 1. I will execute this code within function 1. Then we will accept a callback as an argument. Then we'll have function func2 to do some synchronous code. Function 2 will have tasks 2 through 4. After task 1 is complete, I will invoke my callback to function 2. So with an arrow function, I have more than one line of code. I need to add a set of curly braces. After task 1, I will invoke that callback. So then, if I call function 1, I have to pass a callback to function 2. So now, function 1 is asynchronous, but I need this synchronous code to execute after task 1 is complete. And now that should work. 1, 2, 3. There it is. We have task 1, which is asynchronous, followed by task 2, task 3, and task 4. So by using callbacks, that's one way in which we can handle asynchronous code. But we still need to discuss promises, async, and await, which are future topics. Alright everybody, so that is what asynchronous code is. Synchronous code executes line by line consecutively in a sequential manner. Asynchronous code allows multiple operations to be performed concurrently without waiting. Asynchronous code doesn't block the execution flow and allows the rest of the program to continue. Asynchronous code is commonly found with input-output operations, network requests, and fetching data, usually anything that takes an indeterminate amount of time. And well, everybody, that's what asynchronous code is in JavaScript. Hey people, so in today's video I'm going to explain error objects in JavaScript and how to handle them. An error is an object that is created to represent a problem that occurs. Errors occur often, usually when we accept user input or establish a connection. It's an object that's created to represent a problem. So for example, I am going to console.log the word hello. And then afterwards, I'm going to display a message to indicate that we have reached the end of the program. You have reached the end. This runs as it should, right? Let's say I misspell log as leg. Well, we encounter an uncaught type error. There's many different types of errors. Console.leg is not a function. Type errors tend to happen when we try and access something within an object that doesn't exist. One big issue that we run into is that we prematurely exit the program. It never finishes executing. We have not reached the end. Errors, when they're uncaught, interrupt the normal flow of our program. Another example of an error would be a reference error. I will console.log x, but x isn't defined. We have an uncaught reference error. X is not defined. And again, it interrupts our program. We never reach the end. Errors can be generated for all sorts of issues, such as network issues, promise rejection, which we still need to talk about, and security errors. When we encounter a problem when doing one of these things, an error object will be generated, and it interrupts our program. There's a solution though, and that is to handle these errors when they occur. We can do that with try, catch, and finally blocks. With the try block, we can enclose any code that might potentially cause an error, such as if we're trying to establish a connection to something. If that connection fails, an error can occur. If we don't handle it, it's going to interrupt our program. So all of this code I will place within a try block. We will try all of this code. But we need a catch block too. The catch block has one parameter. It will catch an error object. Then let's console.log the error object to see what it is. So let's run this. We have a reference error. X is not defined. See, now we are reaching the end of the program. The program is not being interrupted. We have gracefully handled this error. Before it was uncaught, but now it's caught. For catching errors, I wouldn't recommend using console.log. Rather, I would use console.error. This will highlight any errors that occur, and still handle them. It's good for debugging. We can clearly see the error. Reference error, X is not defined. And again, it doesn't interrupt our program. We still reach the end. Now, optionally, you can add a finally block. The finally block always executes regardless if an error comes up. The finally block is usually used for closing files, closing connections, or releasing resources. Usually when you open something or establish a connection, you need to close it afterwards. You don't want to leave it open. That's where the finally block comes in. Do any cleanup at the end, whether or not an error occurs. So just to test this, I'm going to console.log this always executes. I'm going to console.log x. We have a reference error. It is caught, so it doesn't interrupt anything. We're still executing the finally block, and we reach the end of our program. If we don't run into any errors, I'm going to console.log hello. There are no errors that occur. We don't end up catching anything. This always executes, the finally block, and we reach the end of our program. So any code that is considered dangerous, where it could cause an error, you'll want to surround with a try block, and then catch them. In the future, if you ever open any files or establish a connection, you'll want to finally block to close those connections, but we haven't discussed that yet. Errors can also occur when accepting user input, because we don't know what the user is going to type in. In a worst case scenario, a user could type in a malicious script. In this next example, I'm going to create a constant for a dividend and a divisor. Const dividend equals window.prompt enter a dividend. With division, a dividend is the number that is being divided. And we need a divisor. A divisor is the number we're dividing by. Enter a divisor. Then I'm going to create a constant, result. Result equals our dividend divided by our divisor. Console.log the result. What is 1 divided by 2? 0.5. Now, mathematically speaking, we can't divide a number by 0. If you attempt to do this in JavaScript, I will divide 1 by 0. You end up with infinity. We can intentionally cause errors, then handle them with try, catch, and optionally finally blocks. So this code is considered dangerous. I'll place it within a try block. We need to catch any errors. Catch an error object if it occurs, then console.error the error object. So just to test this, instead of console.log, I'll misspell log as leg. I should probably add a message just to confirm that we have reached the end. You have reached the end. 1 divided by 0. Type error, console.leg is not a function, but we still reach the end. Our program isn't interrupted. Within a try block, in certain situations, we can intentionally cause an error. I'm going to use an if statement. If our divisor is equal to 0, then I will throw a new error object. We're calling the error constructor to construct a new error object. Within the constructor, we have one argument we can pass in, a message. What is the error going to say? You can't divide by 0. Okay, let's try this. Enter a dividend 1, enter a divisor. I'll type in 0, then press OK. We have a caught error. You can't divide by 0. Our program isn't interrupted. We still reach the end. Let's change console.lag back to log, because I forgot to do that. What if somebody attempts to type in something that's not a number? Enter a dividend 1, enter a divisor. I'll type in the word pizza. Not a number. You have reached the end. I would like to throw a new error when somebody doesn't type in a number. What I can do is that with our prompt, I will typecast it as a number. If somebody enters in some non-numeric characters for either the dividend or the divisor, we will store within there not a number. So let's check that with an if statement. If is not a number. If our dividend is not a number, or our divisor is not a number, let's throw a new error. Throw new error. Values must be a number. I will divide 1 by the word pizza. Error. Values must be a number. We still reach the end of our program. With error objects, you can even create your own in certain situations, and then you can handle them however you want. Alright everybody, so those are error objects and how to handle them. An error is an object that is created to represent a problem that occurs. They occur often with user input or establishing some sort of connection. To handle them, you can use try, catch, and optionally, finally blocks, which are mostly used for cleanup. If there's any code that can cause an error, place it within a try block, and catch any errors that happen. And well everybody, that is how to handle errors in JavaScript. Hey, what's going on everybody? In today's video, we're going to create a calculator program using HTML, CSS, and JavaScript. So let's get started. All right, let's do this thing, everybody. We have a lot of buttons to create, but we'll need a container. I will create a div element. The div element will have an ID of calculator. Within this div element, we'll create an input element. The input element will have an ID of display to display the numbers that we type in. I don't want somebody to enter in some text for the display. I would like this display to be read-only. I will add the read-only property, so we can't type in anything even though I'm trying. I will create a nested div element that has an ID of keys for all of the keys. We need to add a lot of buttons. We'll begin with the first. I will create a button element. The text on the button will be plus. I will set the onClick attribute of this button to be a JavaScript function. We still need to define this function. Eventually, we'll create a append to display function. We have one argument to pass into this JavaScript function, a character of plus. That's our first button. Let's copy this button and paste it 13 additional times, if I counted right. Okay, the second button will be 7. The character we're passing in is 7, followed by 8, 9, minus 4, 5, 6, asterisk for multiplication, 1, 2, 3, / for division, then 0.